Hello, wonderful people of the internet. Welcome back to another episode of Laos Labs. Okay, so today we're going to start with a little bit of algorithm archive work. Before hopping into just continuing with the parallel algorithms, specifically histogram generation that we've been working on for the past, I guess, few weeks now. Once we get that done, hopefully we can keep going on with the research that we're doing in terms of just parallel methods and all this kind of stuff. Okay, before getting started today, okay, let's see if I can, enunciate a sentence properly. I just wanted to say that we will be, this morning I actually picked up a new camera. It is a Sony Alpha 6100 or something like this. I'm going to be using that for my upcoming video, which should be coming out this weekend. I've given a lot of thought to how I'm going to put out videos in the near future, and I'm just fairly confident that the correct course of action is to just put out as much content as best I can. I shouldn't wait to put videos out. Some of the videos might end up on my side channel. I'm not really sure. I know a lot of people probably don't care that much about like video editing and this type of stuff. So I probably won't be doing that too much on stream, and I'm going to try to get that all done in the mornings from like 9 to noon or maybe really early in the morning before going to work out, this kind of stuff. Just want to let everyone know that that's probably where most of my time is going to be spent off stream, just doing video editing and all that kind of stuff. Okay. With that said, I think we can go ahead and hop into an algorithm archive PR. This one should be relatively quick. It's just solving an issue that we had with the algorithm archive recently. Let's go to github.com. Sure, this one will do. It doesn't really matter as long as we get to GitHub. Algorithm archive. Right, and let me just go to the GitHub pages branch down here. Right, so in this branch, you'll notice that it looks like things are failing, right? So let's go ahead and take a look at the details here. Move this up there, move this over here. Perfect. Okay, so these are all failing because it says the tag method in line 109 is not a recognized liquid tag. I did a bit of searching for this, and the only thing I could find is that GitHub seems to be thinking that for some reason all of the markdown files are by default Jekyll files, which is not the type of file that we have. So, I figure let's just go ahead and put in a .nojekyll in the repository. That should hopefully fix the issue. So this is a quick thing to go ahead and do, and I'm just going to do it right now. So cd projects algorithm archive. Sure, ls here, git branch, git checkout, master, git pull upstream, master, git push, origin, master. All right. And then from there, I should just be able to do git checkout -b, no Jekyll. I think that's how you spell Jekyll. Sorry, -b, not -n. I don't even know how I see they're right next to each other on the keyboard. And then I'm just going to run touch .nojekyll. And I think that's all I have to do. Git add .nojekyll. Let me just double check. NoJekyll GitHub pages. And let's see what we can find. Again, if you guys have any comments, questions, concerns, ideas, anything like that, feel free to let me know. Otherwise, I'm just going to keep going with the assumption that people here are just kind of lurking in the background. Bypassing Jekyll on GitHub pages, and basically it's now possible to completely bypass Jekyll by Jekyll processing on GitHub pages by creating a file named .nojekyll in the root of your pages repo and pushing it to GitHub. All right, let's just see what happens. Git commit -m, adding a nojekyll file, git push origin nojekyll. Come on. And perfect, over here, there, go to the algorithm archive. And I think it's fine to push it to the master branch, but okay, so this is an attempt to fix some of the build errors on the GitHub pages branch. In this case, how do I put this? Hey Henry, how are you? In this case, it seems like GitHub pages is assuming a Jekyll backend when we are, oh, I misspelled backend. In fact, does it have dash? I don't know. Backend when we are clearly not using HonKit. By the way, Kurad, thank you so much for following. Really appreciate it. Okay, let me just go ahead and link an issue, which I have in the off-topic channel. No, general channel, AAA channel. This one. Copy link and paste it here. These guys seem to have a similar problem. All right, let's go here and there. And paste this here. Okay, I think this is right. Let me just double check. Grab this link. 1 second. Over here, grab this link here, paste it there, enter. I'm gonna say that this is probably the issue. These guys have a similar problem. Seem to have had a similar problem. Right, I'm just gonna put the period there and create the pull request. And then I want to add as a reviewer and Tyndall. There. Okay, that's all I needed to do. And just see what they have to say. So I can add labels and stuff, but I don't think it's that important. This is a really quick PR. I could do more PRs, but I kind of want to do more later on in stream. So I think for now, I'm actually going to move back into the parallel computing stuff, and we're going to see how it goes. I do recognize there aren't too many people here right now, which is totally fine. I guess now I do maybe want to ask you guys, you know, I'm always self-conscious about the stream, and I'm not super confident as to the best way to make stream content and all that kind of stuff. To me, I don't know if it makes sense to, I don't know, basically what I'm asking about is background music. I do not have background music on this stream. Again, with the intention that I'm going to be taking clips from this stream and turning them into YouTube videos. But I'm wondering if that's actually good or bad. I have no idea. I can add it back in, but it seemed like yesterday most people didn't even recognize there was background music, which was kind of weird to me because I don't know, like sometimes the music is too loud, sometimes it's too quiet. It's just hard to find a right middle ground. So anyway, it is what it is. I'm going to have no background music for today's stream. If people complain about it, I might turn it back on. We'll see. Right. Okay. So with that said, I think we can move right into the parallel computing part of today's stream. I'm not sure how long today's stream will be. Again, at the end of this month, I am hoping to have more or less full-time streaming hours. And we can go from there. I don't like background music. I can always play my own music if I want, but I can't take it away. That's fair. I like it without the music. Okay, fair enough. Yeah, so the truth is, you know, even though a lot of people say they like it without the music because, you know, they can put their own music on in the background, right? Like, you know, the truth is, if you're in the middle of doing like, I mean, anything on stream, and people pop in at random and they have no idea what's going on. Sometimes just having a little bit of music in the background to give that vibe of what you're trying to get is super helpful. I don't know, like sometimes I like it, sometimes I don't. It just depends on the streamer. How are you? I'm doing great. How about you? We just put in a PR for the algorithm archive, and yeah, we're gonna move on to the parallel computing stuff now-ish. And we're going to be hopping back and forth between the algorithm archive and GPU stuff. I didn't know how to label today's stream. I could go back to like histogram stuff. I'm just really not sure what to do with it. So we're going to leave it as algorithms and GPU engineering, which isn't the most engaging title. I get that. But hey, it is what it is. So let's go over here. We are going to CD into projects, CD Simuleos, histograms. Over here, we're going to CD into projects, Simuleos, and histograms. Now, if you were here yesterday, you may or may not have seen me talk about an issue that we had last week. I'm going to talk about that issue one more time because I was looking at the footage yesterday and I realized, again, back to the background music issue, I didn't quite like how it came out. So I'm going to try it one more time. With the intention of using this clip directly in a YouTube video, just, you know, see how people like it. Like I said before, I'm planning to use my second channel as more or less like a clip channel. So this video that I'm making might end up being on the second channel, but I think maybe just having like telling these somewhat smaller stories, I think could be quite helpful for the main channel as well. So I'm basically going to edit up the video, and then once it's edited, I'm going to see if it makes sense to be on the main channel or the second channel or whatever. If you guys don't know what I'm talking about for that, let me just go over here and just go to youtube.com. And I have two channels. One is Leos Labs, which most people know about here, which is, kind of my main channel. But then I have a second channel here, which is Leos Labs Live, which is, I've been basically putting videos up very regularly on this channel. Like basically every day I've been putting videos out. There should have been a video. Wait, what happened? Where's the video that came out? Oh, here it is. Right. So that's the video I put out last night. It's just really easy to make clip videos. And honestly, I've been kind of like when I go to YouTube, right? I don't know why, but I don't click on videos that are over like 2 minutes long. So for me, the clip channels are kind of the ones that I end up clicking on more than any other channel. So I figure, why not give it a shot and try to make a clip channel as well? Also, I will be putting longer form content on there, like, of the order of, 10 minutes or something like that. 1 second, I'm going to try something. I'm going to change my video capture here, and I'm going to change the resolution up, and then I'm going to change it back down again. Okay, and see if that fixes, because I thought there might have been audio video desync. Okay, with all that done, let me go to clear here, and let me introduce the problem that we had basically a week ago, and then we're going to get into the new stuff in just a bit. So if you guys have seen this before, fair enough. I have talked about this many times on the channel before, but I think it's really important just to kind of talk about it a few more times. Okay, I'm sorry. I just ended up talking way too much. All right, so we're going to go into VI minimum working example 2.jl, and I'm just going to delete this and delete that, and go over here, run Julia. Okay, so the other day we ran into a bit of a problem with kernel abstractions, right? So let me just show you what the problem was. Here I'm going to do TID is going to be equal to @index global, come on, of local linear. And then I'm going to say int32 of TID. I think that's right. I misspelled int. Totally fine. This is essentially me creating a for loop in Julia. So the way kernel abstractions works is it allows for you to write a single piece of code that can execute on either the CPU or the GPU, depending on how you want to dispatch it, right? So here we're dispatching it based on the type of A. If A is an array, then it's going to be using the CPU version. If it's anything else, namely a coup array, it's going to be using the CUDA version. So we're going to run this code first on the CPU, and I'll show you guys that right now by just running f test on just a bunch of zeros of 10. Here, I think that'll do it. 1 second. Yeah, run this, and everything should work just fine. Now I'm going to run it again, but this time on a coup array, i.e. a CUDA array, therefore running it on the GPU. And when I run this, we should get a relatively long error, kind of like this indecipherable error, right? And the point here is to show that essentially, in the act of rewriting this kernel to execute on various hardware, I need to wait here. I screwed up somewhere. I'm not sure where I screwed up. Let me try this again. Include. Okay, let me figure out what I did wrong. This should produce a giant, like, incredibly long error, but it's not. Let me give that a go and see what happens. And then I'll talk about what's happening with the error in just a second. Again, if you guys have comments, questions, concerns, anything like that, just let me know. Give this a second. Why is it working? Let me just run st. Did I update kernel abstractions? Okay, let me just see. Q, right quit. Oh, maybe, no? Oh. Okay, well that explains why it worked. All right, let me just redo this whole thing because clearly I'm an idiot. I forgot to write to file. That's why everything was working fine. Okay, let me just redo the whole thing and just start from the scratch. So let me create a new terminal. TID is going to be... Let me start with a new kernel and I'll explain it all. Let me go. So TID is going to be equal to @index of global of linear. Okay, and then we're going to say int32 of TID. I'm going to write that. I'm going to go over here, run Julia, and then we're going to include that file. So again, the way kernel abstractions works is it takes the code that you've written and it basically rewrites it. It overdubs it with a program called cassette into a form that can then be read by either the CPU or the GPU, depending on how you dispatch it. So if we dispatch this on a CPU array, just a normal array, everything should work just fine. But if we instead run this on a CUDA array, i.e. one that's running on the GPU, an NVIDIA GPU using CUDA, everything should break, I hope, if I've written this code correctly, in a kind of spectacular fashion, right? And I want to explain what the error is, why it's interesting, all of that kind of stuff. Okay, so here's the error message. It's kind of long. It's like 100 lines long, right? And at the very top here, you say, you see reason for this error message. The reason for this error message is an unsupported call to the Julia runtime called to JLF tuple. And, you know, if you're looking at this for the first time, like I was looking at this for the first time, I genuinely had no idea how this call could have created a tuple at all, right? And so this is why I think it's an interesting topic for a video, because I don't know, I just feel like, you know, it's kind of interesting. Where is the tuple coming from? How do we exactly deal with these types of errors? And moreover, this is kind of like the daily type of stuff that I deal with pretty much all the time, right? So how do you read this exactly? We're creating an @kernel here, which basically grabs a thread ID, which is the same as your like iterable variable in like a for loop or something like that. So if you have for I is equal to 1 to 10, the I there will be any number between 1 and 10. Here, your thread ID is based on your ND range, which is the size of A. So my thread ID in this case could be anywhere from 1 to the maximum size of A. In this case, A is of size 10. So the thread ID will be between 1 and 10. And what it does is it creates an int64 value. It creates an int64 value that we're then casting onto an int32 value for the thread ID. This line right here is the one that's breaking. And obviously looking at this error message, it's kind of impossible to tell exactly what's going on. But it does give us kind of a hint here with the throw in exact error. So I'm going to take a look at that really quick. So I'm going to do Julia. And essentially throw in exact errors occur anytime you cannot exactly represent a number as an integer. So for example, if I say int32 of 1.0, this is going to work just fine. But if I do int32 of 1.2, this is going to break because we cannot exactly represent 1.2 as an integer without doing some sort of rounding. So if I do ceil of 1.2, maybe onto an integer of 1.2, this is going to work fine. And of course I can do floor. And I can also do round as well, and these all do the same thing. Now, I know what you're thinking, right? In the case of the kernel that we were writing before, we're not doing a float to integer conversion. We're doing integer to integer conversion. And in that case, what exactly do you do? How exactly could you get an How exactly could you get an inexact error? Well, this is basically caused anytime you're trying to convert from like a 64-bit value to a 32-bit value, and there isn't enough space on 32 bits to adequately represent the number, right? So if we say int32 of 1, obviously everything is fine. But if we do a large number like this, now we get the inexact error because we can't truncate the 64-bit value into 32 bits. Now look, there's still a lot of like little things here, right? If I go back to the file, I mean, like I said, thread ID is only from 1 to 10, right? So it doesn't really make sense as to why we're even calling the throw inexact error at all. But if we look into the Julia source code, I think we can find a little bit more information. So if I edit int32 of 1, 2, 3, 4 or something like this, what this is going to do is bring me to the code where this is called, and it says it calls to int32. If I look at the error message over here, we see that, okay, well, the error is appearing at line 602. So let's go to line 602. Okay. And remember, what we're looking for here is an unsupported call to the Julia runtime JLF tuple. And we see right here at the throw inexact error that actually we do have an unsupported call right here. This here is the generation of a tuple. And this is kind of the core problem. I'm going to move this down to the next line so it's a little bit easier to see. But this is a tuple. This is a tuple that we're generating, and this is the whole problem, right? And if you look at it, it's not a problem with the runtime, right? It's not a problem with running the GPU code. In fact, it's a problem with compiling the GPU code, because the way kernel abstractions works is it takes your code and it rewrites it onto either the CPU or GPU. As it's going through the compilation pipeline, it's unable to create a tuple on the GPU. And that's the core issue here, right? So in the compilation of this function, in the potential case that you do have to throw this in exact error, it breaks. And even though I said that, we're not directly dealing with float to integer conversions in the file that I wrote, actually the float to integer conversions of CL, floor, and round were also all broken in kernel abstractions as well. So with all of that said, we're now running into an issue where we have to find a way to get around this throw in exact error. And luckily, the solution is kind of easy. In the same way that kernel abstractions can rewrite your code, you can basically rewrite it so anytime you throw in exact error, it doesn't create this tuple, but instead just runs this command directly. And that was the solution. However, it took me like an extra day or two to figure this out, because the throw in exact error isn't in base Julia, it's in core Julia. So if I do throw base dot inexact error, it's not found. But if I do core dot inexact error, core dot something dot inexact error, it's found there. So basically, finding the exact command took me an extra day or two. But once we got all this done, we're now able to effectively create 32-bit integers, and now we're able to continue with the other stuff that we want to do on the GPU, like the creation of parallel histograms and all that kind of stuff. So anyway, I'm sorry that was a bit long. I'm going to edit that down for the video. And I'm also going to have myself speaking to a camera as well. So it's going to be kind of like, I might not use any of that audio actually, but there is a chance that I do use that audio. I might flip back and forth between like me on camera and me in the video. I don't know. I'll figure it out. But in essence, that's the video that I wanted to create, just talking about the error and explaining that, hey, sometimes stuff can just go catastrophically wrong, and it's kind of difficult to figure out. It's kind of difficult to predict exactly how and when that's going to happen. Anyway, let me just keep going. The next video I wanted to put out after that one is actually going to be on something I did a long time ago, which was a blind programming challenge where I essentially programmed Monte Carlo without being able to see my terminal. It was actually a lot of fun, but I just haven't been able to figure out a way to tell those stories on my main channel before. So I'm basically going to give it a shot, see if I can figure it out. I think with the right editing, I think it can actually work out pretty well. But I mean, that's every story, right? Like, the story, like the narrative of a video is told through editing, right? In the same way that the narrative of a story is told through, actually writing, like through, pen to paper. The act of writing the story or the act of painting is the same way as like how artistic stories are told. It's like editing is just how video stories are told. Like you just have to, figure out the right way to frame everything so that it seems interesting to people, Okay, that was a long roundabout way for me to say. We can now continue with the project that we're working on. So let me do Control D. Over here, I'm going to do Control D again. I'm going to first go into CD projects, CD, and then CD into projects, kernel abstractions, git branch, and then we're going to git checkout master, and git pull. Do I have an upstream? I think it's git pull upstream master, I think that's it. Well, maybe I typed in my password wrong, but yeah, okay, perfect. The convert.jl test, right, that's one that I wrote. We have the test suite.jl. Yeah, these are all changes that I made. Perfect. Cool. And of course, if you guys have any questions, comments, concerns, or anything like that on the stuff I was just talking about, feel free to let me know. It took a long time, but it's done. And like I said before, I need to find a way to tell not less interesting stories, but I need to find a way to tell these stories that are interesting, but interesting in a different way than most of my main content. So I think it is very important to try to make a video about this thing that we did. Okay, so with that said, we can now go ahead and CD to projects and Nuleus and histograms, ls here. And we can work on it. So essentially the last time we were working on histograms, we got our first implementation of a parallel histogram working, which was great. But there were a whole bunch of problems with it, and we'll talk about what those problems are and kind of some solutions to fixing them today. The hope is that we can get at least 2 implementations of parallel histograms like working. Well, okay, at least 1 implementation of parallel histograms working. There are 2 from a 2007 paper that I want to implement, but if we can just get 1 working, I think I'm relatively happy with that. And then the other goal for today's stream is to keep working on some algorithm archive stuff. For example, I have to kind of create a new how to contribute section and all this kind of stuff. So we're going to hop back and forth between a few different things and just see where we go. Okay, so... let me just go into vi histograms.jl, and let me just run Julia over here. Okay, let's go through this code and talk about what it's doing exactly. This is, to some extent, the smallest possible like minimum working example of a piece of code to do a parallel histogram, right? And first, I guess I'll show that it works, kind of, and then second, I'll show how to fix it. So. Let's go ahead and do include, should be histogram in here somewhere. Up here, come on. Okay, apparently, let me just go here. Include histogram.jl. Perfect. I'm going to create a histogram. We'll talk about what exactly is happening after I create this stuff. And yeah, we can go from there. I'm hoping actually to create a new repository called like fastbin.jl, where we have a bunch of these like binning, histogramming libraries available for people to use for basically any project. Maybe even if I think it's good enough, submit it to the Journal of Open Source Software. And if I feel like we do something new, I'm not really sure if we will or will not, but if I feel like we do something new, then I'm going to try to frame it in a way that I can put it onto my main channel. I really am trying to show like new novel research on my main channel. I feel like it's really important to do that. I'm going to create a set of inputs, which is going to be a random number between 1 and 128, and we're going to have 1024 of them. So the first thing I'm going to do is say histogram output is going to be able to create histogram here. We're going to be using plots. I misspelled plots, capital P, perfect. And then we're going to just plot it and see how it goes. But yeah, if you guys have anything you want to talk about, feel free to do so. So let's go ahead and plot histogram output. Output, perfect. And yeah, so what we're doing here is we created a 1024 element array. And each one of those elements could be anywhere from 1 to 128. And then what we did is we tried to ask ourselves the question, how many 1s do we have? How many 2s? How many 3s, 4s, 5s, 6s, 7s, 8s? How many of each of these numbers do we have, right? And we get a range from, 2 to 14, so, or 15, I guess. So the most that we had were like 14, 30s. And the smallest number we had were like 2 of 32 or something like that. So again, this is just a bar graph of how many 1s do we have, how many 2s do we have, so on and so forth. Okay, so now let me show the histogram tag kernel. This was done with the kernel that you see before you, and let's just show that one. I, for some reason, called it histogram kout. I'm not entirely sure why I did that, but this is just me running it to see how it goes. I'm going to first run it with 8 cores on the GPU, which isn't great. Like, honestly, you really should not be running with 8 threads on the GPU, but hey, it's what we're doing. And then I'm going to run the same thing with 1 thread on the CPU. And it should be that with the 1 thread version here should technically provide the same output as the histogram that we just had. Give this guy a second to run. It's kind of pre-compiling a bunch of stuff on the GPU, and then we can go from there. Okay. Perfect. Okay. This was a little bit different than what I anticipated. I guess that's fine. Let me try running this on I'm going to call kout2, and I'm going to run this on the CPU now. And we're just going to run it on the array of input. Interesting. And now let me run it again, but this time with 1 core, and this is going to be histogram kout3. Bad names, I know, but it is what it is. Okay, so first, let's go ahead and run just plot histogram output. So this is the correct histogram. Next, I'm going to plot, on top of that, histogram kout3, which should be pretty similar. I think 3, I think. Yeah, 3. Yeah, it's literally the same. This is running on 1 core in the CPU. Histogram kout2. This shouldn't be so similar, but it is actually the same. That's interesting. Okay, come on. Julia, please. Okay, let's go over here. Perfect. Actually, it's surprising it's the same. I'm very surprised that's the same. Okay, anyway, it doesn't matter. Now let's plot the GPU version. K out 1. Just K out. Oh, I forgot it's a coup ray. Let's do Control C. Oh no, everything's broken. Okay, give me a second. My bad. And then we'll try to fix it. Come on, please. Okay, well, give it a second to quit. The issue was I needed to convert it. Oh, there it is. It's there anyway. Fine, fair enough. So here's the coup array at the bottom. Let me just plot on top of this histogram K out, but I'm going to convert this to an array first, just to make sure it is actually the same value. So we're going to plot that. Okay, perfect. So what we see here is that for some reason, the CPU version works regardless of the number of cores. That's kind of surprising to me, but it does seem to work regardless of the number of cores. But the GPU version is just not working appropriately. And this is what we're going to try to solve today. There's a couple different ways to do it. In addition to this, I'm hoping to get like one good version of this working. And then once we have that working, I'm actually hoping to take a second and try to do some benchmarking as well. That's kind of the goal for today, just to see if we can see what the CPU speeds look like and see if we can kind of get the GPU version. I don't know. I mean, the GPU version should be relatively quick, but we'll do some performance testing and stuff like that as well. Okay, let me go ahead and close that. I'm actually going to be right back before we hop into it. So give me just a minute, and yeah, I'll see you in just a second. There's actually a good question here about parallel and time algorithms. Should be up again. Yep. I studied numerical methods in grad school. You ever heard of parallel and time algorithms? So the answer is yes. I tried. Okay, so to be fair, I haven't used them too much. But like for example, the parareal algorithm, which is a type of shooting method that you parallelize over. Parareal method. I think this is the one that I'm interested in doing. However, I never actually implemented any. Okay, I did a basic implementation, but I never used it for anything, right? But this is the only one I'm really familiar with at all. But if there are other methods here that people do, I don't know. I mean, maybe we should look into them. I actually, the problem with parallelizing across time, and this is where I'm not entirely sure the best way to do this. My initial impression, and this could be completely wrong, but my initial impression with parallel and time algorithms was that it was hard to massively parallelize these. Like doing them on the CPU made a lot of sense, but moving to the GPU kind of didn't make as much sense. But maybe that's because I didn't understand the premise enough. And it was so long ago. It was one of the first things I did as a graduate student. So could have been that I just didn't, I had the completely wrong impression here. And that actually adding more cores makes it better. I never did the scaling analysis here, which is something I do actually want to add, like parallel methods and stuff to the algorithm archive relatively soon. And I'm not sure what I want to do for like scaling properties and stuff like that. Should we talk about strong and weak scaling? We should, right? But then in that case, I don't actually have the tools to do strong and weak scaling like measurements right now. I don't have a big cluster available to do this with. Again, I could kind of fake it a bit. But right now, like literally all I have is like a GTX 970, which is a super old GPU. And yeah, I could technically use some of the clusters that they have in the Julia Lab still, but I need to get back talking to people in the Julia Lab. It's basically only useful as a layer on top of other methods of parallelism if you have unused capacity. Right, that's kind of what I thought as well. Now looking at it, at the time I had not considered... No, I think this is a bad idea. I thought maybe if you do like a distributed GPU type of thing, I thought, maybe that could be quite good. But the issue with that is that, obviously you're going to have the GPU talk to the other GPU at some point, and anytime you have cross-GPU communication, I mean, you're really trying to limit that, right? So, I don't know. I really don't know. I have not seen them used too much in the wild. I think that could be because people are happy enough with their already existing parallelism schemes. Or it could be that we haven't really seen the breakthrough in the parallel and time algorithms to make them like really that efficient. However, I do kind of feel like doing talking about parallel and time algorithms is something I think would be quite nice. Like I think some people might like that. Like people could get some sort of benefit from that. Anyway, let's go and let's talk through this kernel, talk about what it's doing, and just kind of try to figure it out one step at a time. So at kernel function histogram tag kernel. So I called it histogram tag kernel because we're going to be implementing a method with this kernel that has to do with tagging the data, and we'll get into that in just a second. So the first thing I'm doing is I'm creating a thread ID and a local ID. The thread ID is like what element of the index, like which element of the array you're working on. So if you have a 1024 element array, this is going to range from 1 to 1024. The LID is the local ID. This is going to be going from 0 to 8 if you're running with 8 threads. So it's going between 1 and the number of threads that you have. So let me try running this one more time, the cuArray version. But this time I want to run it with 256 threads. Oh, it should have been running with 256 threads to begin with. Oh, that's exactly the problem. I see. Okay, never mind. I think I got it now. I know the reason why the CUDA version was so bad now, because it was running with 256 threads by default, and that was kind of the issue. Perfect. Okay. I could drop that, but anyway, let's just talk through the code. Okay, so the first thing I do is I create an @uniform GS and an @uniform N. These are just for notational sake. It actually doesn't help in any way. In fact, it might hurt a bit. I think, usually on the GPU, if you can trade out a little bit of computation for a little bit less memory management, that's usually a good idea. So creating these kind of auxiliary variables here might actually, waste us like a nanosecond or something. But ultimately, I think it's fine for now. If I actually think it's going to be an issue, we can do some benchmarking later. I think that's more of like a hyper optimization that doesn't really matter for now. Okay, so then the next thing I do is I actually create a shared histogram. Here, sorry, that's where I create the shared histogram. So for those of you guys who may not know the memory architecture of GPUs, essentially the way it works is you have a large global memory pool, which is where you essentially keep all of your data, and then you have a smaller, we'll call it local memory pool, which is what they call it in kernel abstractions here. It's essentially a pool of data that is kept by all of the threads on each block. So for example, if you're running with 256 threads, then kind of all the threads in that 256 block will have access to this data. The reason you want to use a shared histogram or a shared memory tile as opposed to a global memory tile is that there's a little bit of latency anytime that you have to go back and forth to global memory. And unfortunately, when you have a little bit of latency, that adds up when you have to do a lot of operations, and it ends up making certain operations just way, way, way slower if you have to go back and forth to global memory. So having a shared memory tile really does help you speed up the process. It also means that if you're doing non-coalesced memory accesses, i.e. memory accesses that are not adjacent to each other, it speeds up that process as well. I was thinking about doing a short discussion of memory coalescence on my primary YouTube channel, because it's one of those things that I actually didn't understand for a while until basically I took a second to think about what was happening. And then there's a very clear description of what's happening with memory coalescence that I feel like people don't talk about too much. And I kind of feel like it would be nice to talk about a little bit more. By the way, it's Memo Hamad 1. Thank you so much for following. Really appreciate it. Okay. Then after that, we do an @synchronize. So we create the shared histogram, we set all the elements to 0, and then we do an @synchronize. Now, look, an @synchronize is a barrier. It basically says we don't continue until all of the threads have finished the last operation. This is not necessarily a good thing to do. If you can avoid an @synchronize, you should. But in this case, I don't really see a way around it because we can't guarantee that the shared histogram is all going to be 0. Well, so we just have to set that to begin with. The reason you want to avoid it is just because anytime a thread has to wait on other threads, it's just going to slow down the code, and you just want to avoid that as much as possible. Okay, so now let's get into the actual meat and potatoes of this. So speaking of meat and potatoes, I know this is a bit of a side topic, but I was talking to my wife the other day about potatoes, and I made the claim. She didn't believe me. I made the claim that Irish people were actually naturally more healthy or healthier due to the potatoes that they were eating. And I remember hearing this from somewhere. I don't remember where, or reading this somewhere. I don't remember where it came up from. But if you guys know what I'm talking about how potatoes are super healthy and actually made Irish people way healthier than the average British person at the time, let me know, because I don't know where I got that from, but I know I got it from somewhere, right? I mean, she agreed with me in the end that potatoes are healthy, but obviously if they're fried, they're not healthy, but they're healthy as carbs and stuff like that. But she did not, I don't know, I couldn't find a source for the Irish people being stronger because of potatoes argument. Okay, so let's keep going from there. Here we have 4-min element. Leo's losing his potatoes. I mean, I do eat a few too many potatoes, if I'm honest. It's not that, I don't fry them. I mean, sometimes I'll put them in oil and stuff, but I don't deep fry them or anything. Okay, so here's what we're going to do. We say 4-min element is 1 to group size n. So the idea here is essentially if we have a group size of 256, then we're going to go we're going to basically try to deal with 256 elements at a time. So if we have 1024 elements, we're going to grab the first 256 and then the next 256 and the next 256. Three red, I read that as 3 red potatoes, but 3 red too fast, so thank you so much for following, really appreciate it. Okay, so we say the max element is going to be equal to the min element plus group size minus 1. I think this is fine. We then say if the max element is greater than n, we then truncate it. So the idea is let's say we have 1,000 elements, but we're grabbing bits of 256. So we do 256, 256, 256. At some point, we're going to get 1024 elements that we have to account for, but there's only 1,000 elements in the input. So we have to drop off the last 24, and this is just basically allowing for us to get rid of that last 24. Okay, the next thing here we say if the input of thread ID is greater than the max, if the input of the thread ID is greater than the max element, and the input of the thread ID is less than the max element, then we do @inbounds shared histogram of input of TID minus min element plus equals 1. So this is essentially allowing for us to add to our shared histogram. And I think this is actually why the CPU variant of this was working just fine. No, actually, I don't know why the CPU variant of this was working fine. Let me try running this again with 16 cores or 15 cores or something. and see if it still works okay. But we'll do that in just a second. So the idea here is that we're basically going through all of our input values, and we're going through the first 256, and we're asking, okay, are these between... Oh, no, I think we're doing this the other way around. One second. We are going through all input elements, and then we're checking to see, are any of these between 0 and 256? Then we're asking, are any of these between 256 and 512? Then are any of these between, 512 and 768? Is that 256 plus 512? I think so. So on and so forth. And so we essentially just have to go through a bunch of different like sections like that. And then we say the shared histogram of input of TID minus the min element plus 1 will be adding 1. So if our input is between the two values, let's say 256 and 512, then we just add 1 to that particular value of the shared histogram. And then after all this is done, we @synchronize in the loop. Again, this isn't the best thing to do, but it's kind of a necessary evil at this stage. And then what we do is we say, at inbounds histogram output of LID plus minimum element minus 1 is going to be plus equal shared histogram of LID. All this is doing is basically transferring the shared histogram onto the histogram output. And then we just reset the shared histogram of the local ID equal to 0. So that's all we have right now. Clearly, we do have an issue on the GPU. Let me run this one more time. Okay, let's just plot everything one more time. So we're going to plot, one second, if I can copy anything, histogram output. Here's the histogram we're trying to get. And here's the histogram we get on the Kout 3, I think, on the GPU. No, maybe it's this one. Yeah, it's this one. And let me change this into an array as well. Okay. So the blue is what we're trying to get, and the red is what we're getting. Let me try to move this up here. Clearly, there's something wrong with the CPU. Now, the GPU versions are there's something wrong with the GPU. The CPU versions are all working just fine. So I'm not exactly sure what's happening here, but we're clearly running into issues. And this is what we're going to try to fix today. I think what we're having is an issue with the parallelization. I think the problem is that, you have two threads trying to write to the same location in memory at the same time, and I think this is a problem. So to double check that, I'm actually going to run with a smaller thread count. So we're going to create histogram kout again, but this time I'm going to run with num threads equals to 32. And see if we get a better result. And I'm going to call this histogram kout 4 because I'm wonderful at naming. Give this a second. It doesn't look like it's any better though. All right, we're going to run plot exclamation mark histogram kout of 4. So there could be something else that's fundamentally wrong here. In fact, that looks worse, doesn't it? I thought it'd get better as we drop the thread count, but no, it looks way worse. Meanwhile, the CPU version is working just fine. So, let me try running the CPU version with more cores and see if we break anything. So now we're going to do histogram kout 5. And we're going to do num cores. I think I have 16 cores. Let me double check. Htop. I have, 16 cores, but I don't want to use all of them, so I'm just going to say 12 cores. See what happens. Now we're just going to plot histogram kout 5. Okay. And here we see that apparently everything on the CPU is working just fine because the purple line is directly overlaying the blue line that we had before. Okay, so something's clearly going wrong with the GPU. I am not entirely convinced. I know what's happening. So, oh, no, wait. There is something different. Look at this here. That right there is an issue. Okay, which says to me that there must be some sort of parallelization issue happening that we're just not properly taking into account. Let me mess around a little bit more, see if I can just kind of, I don't know, just mess around a bit. So the next thing I'm going to do is I'm going to do a sum of array of histogram kout of 4. And this gives me 26. It wasn't what I was looking for. Histogram kout is 123. Okay, what I was hoping to see there was like 32 for histogram k out 4 and 256 for histogram k out. The reason I was hoping to see that is because this gives me, like, those were the number of threads that I ran. And so what that would tell me is that there was something wrong with the synchronization from shared memory onto global memory. Look, to be fair, it's not very clear that something like that would happen, but, you know, again, I'm just kind of messing around a bit. Okay, I think the next thing we need to do is just go ahead and implement one of the strategies that I had considered. Again, the histogram tag kernel is called tagging for a reason, and so I think what I'm going to do is just try to implement one of these strategies and see if it works. Let me get some water, and then we can go from there. Again, there aren't too many. Okay, anyway, if you guys have any questions, anything like that, just let me know. I do realize that this is, again, a bit in the weeds, and I had a discussion, like, I don't know, not too long ago on YouTube about like what type of content people actually want to see, specifically on YouTube. But, you know, the truth is a lot of people said they don't like the type of content that is like really technical. They like the more easily graspable, understandable stuff. And this is coming from a channel that talks predominantly about, like, you know, numerical methods and stuff like that. So, yeah, I do understand that this might not be everyone's cup of tea. But I do encourage you, if I'm saying anything that doesn't make sense, or if I'm I'm doing my best to explain it as I go by, but even so, like, you know, there's a lot of tics in the way that I speak. So maybe something didn't come out clearly or something like that. Maybe I was rambling about something and, you know, generally lost the point, all this kind of stuff. Just let me know if you have anything that you want me to talk about. Okay, so let's go ahead and open up a paper and just kind of work through it and try to get this this kernel written. And yeah, once we have this kernel done, I'm going to, yeah, we'll see what we do from there. I am genuinely trying to do like longer streams and like try to make it more engaging and all this kind of stuff. So just let me know if there's something that comes up that you feel like, you know, you'd really want to talk about this or that or all that kind of stuff. Okay, so let's go ahead and open up CD Projects histogram, Simuleos histograms, Simuleos histograms, LS here. And then I think it's just going to be 10.1.1.324.1742.pdf.zob. Perfect. Zonal pp 10.1.zob. Okay. Yes, so this is what I was looking for. Let's go in here. A while ago on stream, we actually read this through to describe what's happening. I'm going to kind of talk about it again here. So we'll read it out and just kind of figure it out together. Right. So what this is doing, this is an old paper from 2007 about efficient histogram algorithms for NVIDIA CUDA-capable devices. Again, in principle, this works on AMD as well, but this is specifically for CUDA devices, and I just, because NVIDIA published a lot of papers like this. Okay, so we have two methods to kind of look at here to avoid the issue I was talking about before of two threads writing to the same location in memory at the same time. One issue is the simulating atomic updates in software. To be fair, we could also probably just use atomics. If I was using like any type of, like if I wasn't using Julia for this, but instead was using just CUDA for C++, I probably could have used some atomic operations and it probably would have worked just fine. But probably would have worked just fine. But we're not doing that. We're using kernel abstractions. So I think simulating the atomics is, I really don't know. Like, I think this paper was written before atomic operations were commonplace. So I think that's why they simulated them here instead of actually just using them outright. I'm not really sure. But the other one is to use collision-free updates. So we're going to start with the tagging method here, simulating atomic updates in software, and then we're going to move on to the next method if we have time. I guess I'm going to read through the section anyway. It's not particularly long, and just kind of talk about what it is that we're going to try to do. So the GPU executes the same instructions for all of the threads of a warp. This allows simulating an atomic update by tagging the data that is being written to with the thread ID within the warp and repeatedly writing to the location until the tagged value can be read without change as shown in listing 2. I think in general we can just do this, right? I don't think we're going to run into too many problems. So I think we can just write this out. Let me try to explain what this is doing. I'll zoom in a little bit. Okay, it's taking a while to zoom in, but we're getting there over here. and go up. And in fact, maybe I open this in a form that I haven't already annotated. So let me just open it up again in Zernal, and we're going to do 10.1.pdf instead of .pdf.zop. We're going to scroll down. What? No. Oh, did I save the PDF? Uh-oh. Ocular 10.1.pdf. Is this already updated? No, it's not. Okay, fine. Let's just do it in Ocular then. Whatever. Doesn't matter. Let's go over here. Perfect. Scroll in. Oh, a little bit too far. There. And let's move over here. Nope. All right. Nope. How do I... There it is. Perfect. Okay, so here's the code that we're going to have to write. I guess we'll start at the start here. It says volatile unsigned int bin. This is just going to be the bin that you're going to write to. So in the case of the code that we were writing to, I think this is the case. I think this is what you're writing to. But this is just going to be the input of thread ID that we had before. Then we say unsigned int tagged, which is going to be, we're going to talk about what that is in a second. And we say bin is going to be the unsigned int of data times bins minus 1. What this is doing is it is, I think C++ naturally floors, but what it's doing is it is basically rounding all the data down to the nearest integer so that we can do the binning or the histogramming. Sorry, there's some noise going on upstairs and I didn't know what was going on. Okay, so the next thing we have here is unsigned int val is equal to histogram bin of 0x07 FFFFFFF. So what this is 27, 27 ones. So it's 5 zeros and 27 ones. What this is doing is it's taking 5 bits of the value and it's basically truncating to 27 bits. So if you had a 32-bit integer, it's now a 27-bit integer. And it's using the 5 bits to hold the thread ID. And the reason you want those 5 bits to hold the thread ID is that 2 to the 5, I think is 256. Let me double check that. 2 raised to the 5. Oh, it is 32, right? Which is your warp number. It's the minimum number. Basically, it is a unique ID between 1 and 32 that you can use to ensure that there are no warp level conflicts happening with your system. So that's what we're dealing with here, and we're just going to try to directly implement this code in kernel abstractions and see what happens. So what I'm going to do now, and this is something I don't often do, I usually try not to do on the GPU, I'm going to try to write a second function that we read into the first function. So in CUDA, I would normally do this with a, there's global, and then there is a host and device. So I'd create a device function here, but because this is kernel abstractions, it should be all neatly inlined, I think. So we're just going to give it a go. So here's going to be called function, and I think I'm just going to call it tag bin or something. And let's just see if we can figure out how we're going to do this. And in here, I'm really typoing a lot here. Sorry about that. Let's go down here and there. Okay. And what we're going to do is we're going to put the tag bin in here. So what we want is at inbounds of, how do we want to do this? I think we're going to do tag bin of, and then we're going to read in the shared histogram of input of TID. Wait, I need to think about the best way to do this. So essentially we have 32 elements along the warp that we're trying to avoid interactions between, right? So we probably want to grab 32 elements at a time. But our shared histogram could be potentially larger than 32, right? So in that case, I guess we want to loop through all potential 32, 32, 32, 32. So in a similar way, we have this max and min element. We also want to go through each batch of 32. Let me see what they actually say in the paper. Is it 32? For this method to work, one needs to ensure that the histogram array can only be updated by one warp and the frequency of samples does not exceed 32 minus log 2 of W, where W is a warp size. For an 8800 GTX, the warp size is 32 and the frequency of samples cannot exceed 2 to the 27. Okay, so I kind of read that. It's like, there's not a level of, what if I try doing this? Yeah, perfect. That's what I need. Okay. So when I read this initially, I was kind of like, okay, this is fine. I don't need to think about this, but maybe we do actually need to think about this a bit. Because, yeah, how do we actually implement this in code? How do we actually get this done? I'm not entirely sure. So what exactly is a frequency of a sample in this case? That I don't know. What does it mean by frequency of the sample? I guess we're just gonna have to figure that out. At each iteration, at least one of the threads within the warp is guaranteed to succeed. So the worst case scenario is that the loop has to be executed W times, where W is the warp size. I actually think I don't understand how they're implementing this. So here's what I'm gonna do. I'm actually gonna take a break. I'm gonna read through this paper on my own. I just dropped my pencil. Give me a second. I need to get that. 1 second. Yeah. The problem is I use a drawing tablet as a pencil and it just went all over the... 1 second. Where is it? Are you kidding me? Oh my gosh. Okay, got it. I'm going to take a quick... not break, I'm just going to read through the paper on my own and see if I can actually write down the pseudocode. I thought we had the pseudocode, but now I realize there's some stuff that I just don't understand about this. And I'm just going to try to figure that out. So I'll be back in like an hour or two once I figure it out. And we can do that and do some algorithm archive work and just kind of mess around with it a bit. Well, I mean, the thing is I could do this on stream. The problem is anytime I try to do problem solving on stream, it just doesn't go very well. I don't know if this is true for anybody else, but when you try to do this type of stuff on stream, it's just hard. Like, and then it ends up being that, like, you know, you end up forgetting something basic, like, you know, how Taylor series works or something. Maybe I should do it on stream. Actually, the more I think about it, the more I need to figure out how to do this type of stuff on stream anyway. So maybe we just kind of work through it, and maybe it's a learned skill that I can figure out. I'll try to give it a go for like an hour or so, and if I feel like I'm not getting anywhere, then then I'll give up and I'll just read the paper and try to figure it out. So my core issue with this is I don't see how this little snippet of code fits into the overall, like, overarching narrative here. You know, like, I don't know if, like, how do I put this? I don't know how to just slot in a function like tag bin function into the code that we're writing. I get how this works, but I guess my question is, you know, if we're essentially only updating at the warp level, right? So that's 32, and our shared histogram can be larger than the warp level. How do you actually, like, do you just go through each warp and you create a new for loop that just goes through each of those? I mean, maybe that's what we do. Yeah, let's just read through and see if we can figure this out. And then we'll just read through it and try to figure it out. Okay. So let's start here again. So for this method to work, one needs to ensure that the histogram array can only be updated by one warp, and the frequency of samples does not exceed 32 log 2 of W. So what does it mean can only be updated by one warp? That is one question I have, and I don't understand exactly what that means. Okay, I'm struggling. Let me try this again. So when we say it can only be updated by one warp, that to me says that we can only have a set of 32 elements acting on the histogram at any given point in time. That's what that says to me. I'm not entirely sure what... I guess we always have that. I think that's always intrinsic to the GPU system, right? Because 32 is the, that's just the minimum number of elements that you work on. So maybe that's fine. Okay, so we'll take that as a granted, we'll take that for granted, just saying this is what always happens on the GPU. We don't have to think about it too much. The next thing says, and the frequency of samples does not exceed 32 minus log 2 of W, where W is the warp size. So my question is, what does that mean? What does the frequency of samples mean? I think that's just like the cadence between, like, you know, you seeing like one value and then another value immediately after, I think. But I don't understand what it means by the frequency of samples cannot exceed 2 to the 27. I don't understand that. So at each iteration, at least one of the threads within the warp is guaranteed to succeed. So the worst case scenario is that the loop has to be executed W times. This is also confusing to me. So it says the worst case scenario is that the loop has to be executed W times, which means that would mean that you have 32 ones in a row. Okay, that's fine. Yeah, okay, that's actually fine. This happens when all threads happen to be writing in the same bin. Right, that's fine. So histogram has to be allocated on the GPU's shared memory for this method to be efficient. However, given the 4K double word 32-bit limit for shared memory, the maximum number of bins can be supported is 4096. Fair enough. We caution against allocating histogram in global memory to overcome this limit, as repeated updates to high latency global memory will significantly reduce the execution speed. So that's actually why we have created the shared histogram and we iterate through different values of the shared histogram. That's why. So the next thing is, we also note that using a single warp underutilizes the GPU resources. For optimal performance, GPUs need around 4 to 8 warps. Right. As such, we need to allocate a separate histogram array for each warp. They have a separate histogram array for each warp. Okay, wait a minute. That kind of explains what's happening. So instead of creating one shared histogram, we split the number of threads into warps, and we create a shared histogram for each warp. Okay, the subhistogram arrays are then combined to produce the final result. Obviously, increasing the number of warps will further limit the number of bins that can be processed per execution of the algorithm. Okay, so let's see if I can write this out. So what we currently have, let's write out what I currently have and what I think needs to be changed to get this to work out. I have not opened up Zernal PP yet, so let me do that. Let's go over here. Open up Zernal PP, move this over here, over there, and over here, over there. Perfect. Okay. So what's going on right now? So right now what we're doing is we are creating a shared histogram, which is going to be equal to the length of the input. No, not the length of the input. Oh, it's the length of the input, or the length of, or the group size. In fact, it should, I think, always be group size, I think is the way that we implement it. So it's always group size. So what is group size? So group size in this case is equal to the number of threads. So on the CPU, it's going to be equal to something on the order of 16 at most. And then on the GPU, it's going to be something probably like 256 or something like this. Okay, so I think what this is saying is that we need to take the shared histogram that we're already creating and say this is actually group size divided by, one second. This is actually group size divided by 32. Right? No. We need group size. Wait. How's this going to go? We want... Okay, no, this is what we want. We want it to be a 2D array. Let me just mess around here. So we want it to be a 2D array. So this is going to be... histogram is going to be equal to... I'm just going to write it this way. Zeros of warp size. And then it should be group size divided by warp size. Here. And I think we probably want the seal of that as well. So we do one up instead of one down. So seal of this. Okay, and I think what this is going to do is it's going to create, basically it's going to partition our histogram into a series of warps, and I think it's going to be fine. So now that we have the series of warps that we can deal with, the next thing is going to be iterating through those shared histograms, and I think the paper is going to explain how we do that. Let me also make this a bit smaller. Let me just make it a little bit smaller. Can I annotate? I think I can. Wow, look at that annotation. Amazing. All right, Control Z. Okay. What else can I do? I can underline. Woohoo! The entirety of the paper is a typo now. All right. What else do I have? I strike through. Perfect. And I've got underline. Great. Why does the underline look different? All right. Perfect. And then I've got tags, stamps. All right. Approved. Oh, welcome to Simuleos, where I just approve everything. It's such a dumb. I don't know why I'm getting a kick out of this. It's just kind of silly. Anyway, it's fine. It's fine. Can I do? No, it's all going to be the same size. It's fine. It doesn't matter. And I can flood fill. Can I do this? And then I can flood fill. No, I can't. Okay. Anyway, I'm spending too much time trying to figure out what I can do. I can also put a note here. Okay, perfect. Let's just highlight for now. Okay. We're going to go through and we'll kind of just write stuff out as we get to it. So we also know that using a single warp underutilizes the GPU. This is what we said before. I'm still a bit concerned over this paragraph in here. Let me do this in like red or something. No, it's not this paragraph. Okay, I do think we kind of understand this. I think it's fine. Okay, on to the next bit. So we also know that using a single warp underutilizes the GPU. Again, I think this is fine. So I think these two paragraphs are relatively understood. Next. To allow calculation of an arbitrary number of bits, we subdivide the bin ranges into a number of sub-ranges that fit in shared memory. Right, so we're already doing this, I think. So to allow for an arbitrary number of bins, here we're going to highlight. For a given execution configuration, we run the algorithm as many times as required to cover the entire bin range. At each iteration, the kernel will only process those data elements which fall in the specified bin range. Okay, let me reread that. For a given execution configuration, we run the algorithm as many times as required to cover the entire bin range. Right, so that's just why we had the shared histogram and we did 1, 2, 3, 4. Perfect. So far, I think we have things reasonably implemented. Knock314, thank you so much for following. Or do you prefer to go by knockpi? Maybe knockpi100? Anyway. Let's keep going. Each iteration, the kernel will only process those data elements which fall in the specified bin range. For example, with 4 warps at a limit of 1024 bins per execution, a 10,000 bin histogram requires 10 iterations of the algorithm. Yes, that makes sense. That's what we're already doing. So this is also easy to do. So figure 2 shows histogram throughput in gigabytes per second. Okay, so this is as much information as they're giving us. So let's just kind of try to piece everything together by going back to the source code. Oh gosh. Okay, so first we have to reorganize the source code. Reorganize the source code so that it makes sense with the new information that we have. So this means a 2-dimensional shared histogram. We are going to break this as it is now, and since it's kind of working, let me just go ahead and write and quit and see if we have it committed to GitHub. The git diff of histograms.jl. Okay, it is currently committed to GitHub, so we can just mess around with it. Worst case scenario, we go back to the previous version. So what are we going to do next? So we have shared histogram in here. Also, I do apologize. If you guys hear something in the background, there's always construction around this apartment. It's just something, there's either construction or there are people that are talking like right outside my window because there's like a restaurant over that direction. There's a restaurant in that direction and there's like a busy street in that direction. It's relatively quiet when the restaurant's not in business or not operating, which is like in the middle of the day and then like really early in the morning or really late at night. But everything else, there's probably going to be background noise that is not background music because I turned the background music off. Okay, so let's just try to figure out how we want to do this. So we want to do tag bin. And the reason I was struggling with this before is I actually don't know what function arguments tag bin takes in. So let's go back over here and let's see if it kind of gives us a little bit more information. Nope, that's not what I wanted to do. How do I scroll? This button? No, I cannot scroll. How do I? Here? Okay, perfect. So then I scroll up here. Right, so this is clearly not a function. It's just like something inbuilt into a kernel. So I need to think about how I would want to write this in terms of a function. And that's what we're going to do next. So we do know for a fact that we want to modify the shared histogram here. We want to modify the shared histogram so that we have multiple... Oh, so the group size is split up. What is it? So we have warp size and the seal of group size over warp size. Right. Now, this does bring us... This is a bit of a problem, right? Because when we think about parallelizing this... we had this really nice kind of shared histogram, or sorry, at inbound shared histogram of LID is equal to 0. We have this like very nice call that we have here. What I might do is I might create a new function that just like sets all the elements of the shared histogram to 0. And what we're going to do is we're just going to run that first, right? So before we deal with the tag bin and everything, let's see if we can get the shared histogram and everything set up so that we can run the rest of the code. Okay. So like I said before, I think the shared histogram needs to be of size, warp size, which I think is going to be 32. I think it's a constant. I think I can do it this way, 32, and then the group size divided by 32, but we want ceil of that. So let's grab ceil here. Okay. Now, we do have a bit of an issue here in that I don't really know how to set them all to 0, so I'm going to create a new function in here, and we're just going to run that function and see if it works. So we're going to go in here, and we're going to say function shared 0 or something. I don't like the name there. Set to 0. Okay, let's just see what this is going to be. This is me just trying to play around with functions and kernel abstraction to see if they're actually appropriately inlined. I think they are, but just to be safe. I think they're all inlined by default. I think. I'm not entirely sure, but I think that's true. Okay, so set to 0. What exactly would we do here? So what we want to do is we want to read in the shared histogram. So I guess I'm just going to call that as A. And we, of course, have a size for A and all this kind of stuff. We have a group size, which we're also going to read in. And then we have a local ID. Yeah, my core issue here is that the group size could be in okay, let's just think about this really quick. So let's say the group size is equal to 256. So GS is equal to 256, right? What this means is we're going to have 256 divided by 32, which is going to be 4, 8, 16. 256 divided by 256 divided by 32. That's going to give us 8. Okay, 8. So this is going to be a 32 by 8 array, right? And in this case, where 256 is directly divisible by 32, we don't have a problem. We can just do shared histogram of LID equals 0. Perfectly fine. Great, no problems. But in the case where the group size is going to be equal to something else, like, let me just go ahead and remove this. So we have group size is equal to 100. Look, admittedly, like almost everyone uses power of 2s, but let's say that's not the case. In this case, we're going to have a 32 by 4 array here, where it actually counts up to 10. It actually counts up to 1, 2, 4. Is that a power of 2? 64 times 2 gives you 128. I'm an idiot. 128. So this guy counts up to 128. But if your group size only goes up to 100, you're going to miss out on the last few elements. Now, my question is, does that matter? Do we need those last few elements? Maybe we don't. Maybe it's okay not to have them. Yeah, maybe. Maybe it's fine. Because, like, yeah, okay. Let's just pretend, let's just say we don't need them. All right, let's just say we can set all the local ID to 0, and this is going to work fine. Okay, then all we're doing is restructuring the shared histogram, and this should, in principle, still run. So let's go ahead and include what we have before with histograms.jl, and let me just run histogram kout with a coup array. All right, it still runs. Let's run this with 256, runs as well, and let's run it with 100. Right, okay, that's broken. Hey, Fortuitous Lover, how are you? Apply type. Oh no, don't tell me this is one of those issues. So if it is a multiple of, wait, what is the issue? We just fixed. Oh, I see the issue. This has to be ceil of int, I think. Let me fix that. Because it's naturally, ceil is going to give you a floating point value. Let's include it one more time. And let's try histogram with number thread 100. Ah, it's still broken. I thought that was it, but it might not be the issue. Okay, let me comment out a lot of this code and see what the actual line is that's broken. Because I have a feeling the line that's broken is not the line I want to be broken. So let's go here. Let's go there. Run this and run include one more time. Oh, up here. Sorry about that. XP right over here, include, and we're going to do histogram kout 4. Perfect. Okay. Let me do one more thing just to make doubly sure that the line that's broken is this line, because this line shouldn't be broken. And if it is broken, we're in a lot of trouble. Oh, no. Okay. I'm just getting flashbacks to the error we were just talking about earlier in stream that I was like, thank goodness this error is fixed, because now that it's fixed, we can like keep moving on with our lives. We don't have to deal with it anymore. And here I am, I think, dealing with the same problem again. So we're just going to see how this goes. I'm a bit concerned, like a bit more concerned than I should be about this. So I'm going to comment this out, dd, paste it up here. All right, perfect. We have the group size, we have n, and we're going to run this. Include histogram kout 4. Okay, that gave us an error. Control D, Julia, include again. Wonderfully engaging content. Now we're going to do histogram kout 4 again. Sure, we need to create the input, which is going to be between 1 and 128. Histogram kout 4 is going to break, I think, but we're double checking just to make sure, and then we can go from there. Oh, I was also thinking, self-similar bugs. It's nice that you're going fractal all the way. Yeah, that's definitely the issue here. Man, it's just, it's so frustrating because, like, you know, there's a certain level of abstraction you want to work on, right? When I was doing stuff for my PhD, I genuinely did not like working on the physics level of abstraction. I felt that was too abstract, like too far away from the stuff I liked working on. But this level of abstraction, the kernel abstractions level, is a bit too deep for me. Like, I like the middle ground where I can write kernels and I can be happy with my life. But I've, so far, only been writing kernels and I haven't gotten the be happy with my life part yet, you know? This ran. It ran. I don't understand why. And I don't think the histogram is right, but we can check really quick using plots. And let's just plot the new histogram. Again, I'm not convinced this is actually going to be good. So plot, what is it? Array of kout 4, what did I call this guy? I'm super bad at naming. Kout 4 is what I called it. Bam. It should all be zeros, right? That's all we're doing. It's all setting it all to 0. So we're going to dd here, and we're going to run the rest of the kernel. Perfect. It's all zeros. Wonderful. All right. Now let's run the rest of the kernel. Over here, we're going to include, and we're going to run this guy again. Hopefully, it still doesn't break. Perfect. We still get all zeros. Let me run it one more time. Julia, include, create a new input, run it again, and see what happens. Oh, also, guys, if you guys notice something, you know, I realize it's a programming stream, right? So, like, you know, there probably isn't too much stuff to clip, but if there is something that I say or do that you think is particularly noteworthy, just let me know, like create a clip. I do go through the clips and I have been putting them on my second channel as of recently. So if you, yeah, if you see something interesting and you want to talk about it, just feel free to do so. Okay, now they're being loud outside again, but that's okay. I don't think this, okay, I just looked at my face on the side screen just to see if there was a video audio desync. I don't think there is. Yeah, I think it's fine. Okay, it should be fine. I know how to fix it now, which is wonderful. Like, genuinely speaking, it had plagued my my streaming career, being unable to fix the video and audio desync for the longest time. Close eBeta, thank you so much for following. Really appreciate it. All right, let's see what happens. We're going to give it a second to run. It's still doing the precompile stuff, and then hopefully we get something out. You know, I'm going to try it again with 300 threads as well. Okay, we get something out. Let me see if it's the exact same as running with 256 threads or not. So we're going to do histogram 2, and we're going to do 256. I don't think it's the same, but it might be similar. So let's see what happens. Anonymous Cheer, thank you so much for the bit. Really appreciate that. Okay. So the next thing I'm going to do is just using plots. and we're going to create the histogram that we actually want, and then we're going to check it against the histograms we created. So histogram output should be up here somewhere. Here, and then we're just going to do plot histogram output, and then we're going to plot the other two on top of that and see what we got. It should be histogram k out and histogram k out 1 or 2 or 1 or 2. I'm not sure. Okay, so use that. Let's do plot exclamation mark of array of histogram k out. Sure. Perfect. Now we do histogram k out 2. All right, perfect. So these are obviously bad plots, but we're getting there. So the blue histogram is the one that we generated on the CPU. That's when we're trying to get. The green and the red histograms are the ones that we actually got. I'm not saying we deserve the blue one. I was trying to make a Batman joke, and honestly, I don't know how to make that one. What is it? So Batman is not the hero you deserve, it's the hero you have? Is that what it is? So these histograms are not the ones we deserve, but they're the ones that we have? Okay, look, man, I just butchered that. Whatever the appropriate way to tell that joke was, I did not do that correctly. I'm sorry about that. Okay, let's keep going. So we have the histogram output of LID plus min element minus 1. I don't think this is the issue. I think the issue is... Okay, I think we're able to create the shared histogram just fine. So the next thing we want to do is try to figure out how to do this tag bin function. Okay, so what are we reading in to the tag bin? I think what we're going to do is we want to read in a particular layer of the shared histogram. I think. And then for this layer, I think we want to read in... I think we want to read in the max and min elements for that layer. So again, the shared histogram now has 4 or 5 layers associated with it. I don't know. It has a certain number of layers. It's a 2D structure now. And we're trying to grab 32 groups, like groups of 32 threads to work on, because 32 threads is your warp number. It's the minimum number of threads that are executed in parallel on the GPU at a time. John Law, thanks so much for following. Also, for some reason, I thought we already had a John Law following on stream. So I'm not sure if you're the same John Law or a different John Law. If so, welcome. It doesn't matter. If you're new or you're old, welcome. Thanks for being here. Okay. So we have @inbound tag bin here. So let me think about how we actually want to do this. I think what I would do is I would say form. I hate this so much. I is equal to 1 to... in groups of 32, no. 1, 2. In fact, we could just do... No. Let's do it this way. So, first time watching? Oh, well, welcome then. I don't know why. Maybe John Law is a common name. I'm not really sure. So we're going to do 1, 2, size of, I don't know, the shared histogram. So, you guys note that I'm being very picky here. And for those of you who don't know GPU engineering, you might be wondering, what does this matter? Why do I care so much about putting a for loop in the middle of a kernel? The reason I care is that for loops they are inherently serial operations that you're putting into something that is parallel, right? You're executing this kernel in parallel. So every time you put a for loop in, if you can find a way to avoid putting a for loop into the code, you are in some sense making the performance better, right? And so this is why I'm being very cautious about what I'm writing here, because I feel like there must be a better way to do this. So I'm going to do shared histogram of, and I think I want to do this in I is what I'm looking for. Yep. And we're going to go down here. And I think then what I want to do is dd here, paste up here, 1, 2, 3, 4. And then I'm just going to do the tag bin function on the shared histogram of, I believe, this and I. And then we need to find the minimum and maximum elements. That's only if the for loop depends on the previous iterations. Well, no, not necessarily, right? Well, okay, it depends on how you want to say this, right? Like for example, I could, if I wanted to, write vector addition entirely with a for loop on the inside of a kernel, so that every single thread executes that vector addition, right? So, like in that case, the for loop would be, you'd get the right code out, but you're redoing a lot of work, right? But I see what you're saying in that. Actually, I think it's totally fine if you have to do, if it depends on previous iterations. Yeah, okay, that's correct. Yeah, like parallel reduction, for example, is quite slow and stuff. Okay, let me go from here. So we have at inbounds tag bin. Mechanology, thank you so much for following. Really appreciate it. Okay, so what I want to do for the tag bin kernel is we're going to read in that group of 32 threads that we're working with. And I think I also need to read in. What do I need to read in here? Again, I'm probably going to unroll this or not unroll it. I'm probably going to put it into the kernel itself. But I'm trying to think, what do I actually need to put in here? So we have the tag bin function. Again, we're going to mess around with it, but for now I'm just trying to reason about what I'm doing here. So we want to grab in the 32 threads. I guess we're just going to further subdivide this. So we say if the input of thread ID, I don't like this very much right here. And the reason I don't like this very much right here is that it's, you could potentially have a warp divergence here because, you have 32 elements along your thread ID. And you could make it so, like half of the threads are in this bin and the other half of the threads are not in this bin. But I don't really see a way around that right now. We can take a look at their C++ code eventually. Like, this is something I want to do. I want to take a look at their C++ code. But I also want to kind of get an implementation down before taking a look at that code, because I feel like this gives me a better understanding of what I'm trying to do, right? So for I is equal to 1 to size of shared histogram at inbounds tag bin, I guess we're going to say shared min, shared max. I'm going to create these variables. We're going to say shared min and then shared max. And we're going to define those in just a second. I'm just going to put these on the next line just because I don't like particularly long rows. Okay, so we have the shared min, the shared max. In principle, we should also be reading in the input of TID. The input of TID, oh geez, I swear I'm really screwing this up. We want the input and then we want the TID and then we want the input and then we want the TID and then we want the local ID. Let's just add them all in here and let's just think about how this is going to go. It's super iffy. So we want the input. In fact, let me put the input on this line over here. Input, shared min, shared max, and then we're just going to do TID and LID. All right. Again, we're going to mess with this. I'm just trying to think about what the function is going to be written, and then we're going to put it in later. Okay, so I think what we're going to do here is write kind of a suboptimal function, one that just works, and then we're going to, iterate from there. So again, I don't like this because we're already running into some, potential thread divergence problems. But on the other hand, I don't really know what's the other way to do this. Do we shuffle the array? I mean, if we pre-sort the array, we don't run into this issue. But I mean, pre-sorting the array, then you run into sorting, which is an equally difficult problem for other reasons, Okay, so let's do tag bin, and let's just make sure we have the appropriate values here. I think this is an exclamation mark as well. And so we're going to do shared histogram. Then I believe it was input, and then it was test as many ways as you can and measure performance stats. Use the best way. Don't assume how the GPU works. Well, I mean, we can make some assumptions of how the GPU works, right? But I agree with you. Like, definitely we need to do performance testing and stuff, right? I called it input instead of input. Wow. Then we want shared min. Bad names, but that's okay. Shared max. And then we want the TID and LID. To make sure that's actually the right number or the right set. So we have the shared histogram, then we have the input, the shared min, the shared max, TID, and LID. Okay, perfect. Okay, so this is where we need like the while loop and stuff in there. It's not going to be pretty, but we're just going to get something working and go from there. Now, one big caveat with this method, again, is that we truncate the numbers. So we have an int32 value. Oh. I didn't. Right. Okay, let's change all the int64s to 32s because I just realized this method does kind of rely on a int int32 value. We can modify it for int64, but right now I'm just trying to get the int32 case working. Yes. Yep. Okay. This could be a problem. I don't think it will be, but maybe it could be a problem. So right now the code should in principle run. We're just not doing anything, right? So let's go and write this, go over here and just include. And now we're going to run histogram tag one more time. Oh, that was not what I meant to do. I don't know why I just clicked that button. This guy. And hopefully it runs. It does not. And it does not because we have dynamic memory allocation, which is fine. And it's because of the GS here. Perfect. Okay. Dynamic function call to colon. Call to colon. Unsupported dynamic function invocation call to colon. Let me check some things here really quick. Let me just go here. I'm going to comment all this out. I thought it was going to tell me that this line was broken. But I think it's telling me that this line is broken, which is not what I was expecting, but might be not bad. Okay, let's keep going. Here. I mean, look, the other solution here is instead of having, a 2D array in shared memory, we have a 1D array in shared memory, or multiple 1D arrays in shared memory. I mean, honestly, it's basically a 1D array in shared memory anyway. The 2D is really just to help us with accessing. And if it's hurting us, if it doesn't help us access anything, then if it doesn't help us write the code, then it doesn't help us anyway. Let's go over here. Let's include it one more time. Let me try running this again. We get another error, and the error is going to be probably the same with the colon. Right. So let me try doing Control D. Julia, include one more time. And I'm just going to run the same code. Again, all I'm doing here is creating a shared histogram, so it should work, I would imagine. And if it doesn't work, then I don't entirely know what to do, but we'll figure it out one step at a time. Okay, so we got the histogram tag. Let's go ahead and create the input. One second. Oh gosh. Over here, let's create the input. Input here. And we're just going to create histogram k out is going to be this. And in fact, let me do 128 here. We're just creating a, this should work. I don't see any reason why this wouldn't work, but again, the reason I open and close Julia is because sometimes the pre-compilation doesn't exactly work super well on the GPU. I got a message I have to take a look at really quick. Give me a second. Here we go. Oh, never mind. It was not a message I had to look at. It was just a random notification from a Slack group that I'm a part of. And I thought it was from, so the same Slack group has the main developer of kernel abstractions. He's also one of my best friends, but I thought he sent me a message and he was like watching stream and being like, hey man, you're an idiot. Okay, this works just fine. Let me try this again with 100. See if that's broken. No, that also works just fine. So I've got a feeling it's actually giving us a problem with this guy right here. So let me go over here, Control D, Julia one more time. And to test that, let me do, how am I going to do this? Let me modify this at inbounds command, paste here. And I guess we're going to say, this is a very bad way to do this. So let me actually put it up here. This is just me trying to test to see if the colon operator actually is the problem or not. So let's just do if LID is less than 32, and here, and we're just going to do, I think it is a colon operator actually, now that I think about it. Shared histogram of colon. Wait, it's 32 along that one, so that should be LID, and then it's colon is equal to 0. Let's see what happens there. We're going to include this guy, and now we're going to create an input and try running it one more time. And in that run, it will probably be, it's probably going to break. This is probably going to break. That's my guess. Let's create an input there, and now we're going to do histogram k out is equal to this. See what happens. Okay, so what I was trying to do was create a subarray to read into the function. The actual solution here might just, again, not to have, might be just not to have a, or maybe I need, Should this be, oh, I need to think about how we're going to do this. I think the colon operator is going to break. That's what I think. I'm pretty sure it makes sense that it's going to break. I don't know why I'm even questioning this. But, you know, whatever. Let's just see what happens. Let me get some water. Okay. There we go. Here we have an issue which we can't debug. What an amazing error message we have here. Man, I'm super stuffy today. Illegal instruction encountered. Yeah, okay, this is what I thought. Oh, also, it is illegal because this has to be dot equals anyway. But I'm pretty sure this is going to break anyway. Let's just try running this one more time without the, you know, obviously wrong syntax. And then we'll try to fix it from there. So we'll keep working on this for a bit. I really am hoping to get at least some implementation of this algorithm working today. You know, I've honestly been working on this for over a week now, 2 weeks now. I've been working on this, so it'd be super nice to get something working. You know, that gives us a reasonable histogram on the GPU. That's really what I'm looking for here. I think it's been over 2 weeks, honestly, because apparently parallel histograms are hard. I knew they were hard. It's one of those problems that seems hard, right? Well, okay, if you don't know, it's one of those things that you definitely have the Dunning-Kruger effect with. If you know nothing about GPUs, you think creating histograms is easy. But then if you know anything about GPUs, you're like, oh no, that sounds really annoying. I had this discussion with Alan Edelman from MIT, and also Dave Sanders when I was teaching the course on computational thinking. And I brought up the point that, you know, creating a parallel reduction is a notoriously difficult problem on the GPU, right? I said that. And then they were like, what? I don't know. No, it's not. Obviously this is easy. I'm like, what do you mean it's easy? You know, textbook, it's one of the first things that you learn in any parallel computing class. It's like, hey, this is a hard problem. Here's why it's a hard problem, and here's how you get around it. It's still hard, but we can make it fast, you know? All right, I'm just going to delete all of this and try running the kernel one more time and just see what happens. Oh, I have an extra I in here. This should be for J. No, I is fine because this is actually fine. Okay, let's go here. We're going to do Control D. Julia, include one more time. We're going to try running it again, see if we get the same error as before. We should, and then we're just going to try to debug and figure out what the actual issue is. So now we're going to create the input again and create the histogram K out. I don't know why I called it K out, but now I'm kind of sticking with it, you know? Just because your code has bad notation doesn't mean it's bad code. Well, actually, that's true. That's wrong. If your code has bad notation, it's bad code, which means I should feel bad for this bad notation here. But anyway, let's just keep going. Man, I'm super stuffy, though. I'm sorry about that. Yeah, also, I don't know. I'm just stuffy. Man. All right, let's see what error message this guy spits out, and then we can go from there. I'm not doing the Swoleos workout stuff today. This isn't because I don't want to. I do actually want to. It's because I recently did a set of deadlifts 2 days ago, and I'm just incredibly sore. It's been 2 years since the last time I did that deadlifts, and man, I just I'm having a lot of trouble walking around. It's not even my back. It's actually my legs. I've never had my legs be sore after deadlifts because we also usually do leg day. But man, I'm just super tired. And so I kind of wanted to take a break, just take a day off. Because we did a 10K run, my wife and I, yesterday as well. So between the deadlifts and the 10K run, I'm actually just quite tired. So I'm like, okay, no workout today. We're going to come back to it tomorrow. Right, so unsupported dynamic function invocation call to colon. Okay, I'm going to be honest, this is probably going to be in the call of tag bin then. We could do an at inline. I don't remember if I put the at inline here. I guess I do, at inline here, right? Well, let's just put it here. And let's see if that's going to do it or not. Let's go ahead and include histogram K out. It's going to give us the same error. So let me just try recompiling, include, and now we're going to do input again. And then I should just be able to run it one more time. And yeah, let's just see what happens. Histogram K out. Here we go. And give it a go. Yeah. Yeah, so I don't know. We'll just see kind of how the next few days go. To be honest, like the creation of a super efficient parallel histogramming method is one of those things that like I don't know, I find kind of interesting, but also like I think maybe might might not make good video content is what I'm trying to say here, because I haven't been able to find a way to spin it to make it interesting. Like all the time I'm trying to be like. And I'm not saying like interesting video content is the end all be all, but I'm saying that like, I am trying to make somewhat interesting content. And the fact that I just can't even find a compelling story for the histogram one is just, it's just annoying is what it is. Okay, so I'm not sure. This must be the function call then. We tried the colon operator and it seemed fine. So let's just try doing this without the function call then and see what happens. I'm still going to. Okay, so then in that case, what we're gonna have to do is we're gonna have to go through one to size of shared histogram 2. 1 second. That might actually have been the problem. Control D, Julia, input, include. I think that might have been the problem. I think I fixed it. Just because I had a wrong, like an improper index. Okay, so now we're gonna do histogram K out. Oh, that whole time, like literally 20 minutes, just trying to figure out, like, oh, it's gonna be so embarrassing if that's actually the case, but that's okay. Like I said before, a lot of this kind of like debugging stuff is stuff I wouldn't normally show on stream, but I'm just trying to, I don't know, I'm trying to make it so I can put like my entire workday on stream, right? And that process of going through all of this debugging is, I think, a learned skill that I just need to figure out how to do on stream, right? Like certainly learning how to debug was something I learned. So learning how to debug publicly is also probably a learned skill. And so it's something that I'm slowly trying to get better at, Okay, let's see if histogram K out actually outputs something. Might not. I might try running this on the CPU as well, just to see if this is specifically a GPU problem. Yeah, let me try running this on the CPU and see what we got. This also gives us an error. It says undefined. No way. No freaking way. Are you kidding me? Is that what the error was the whole time? Oh, thank goodness. Oh, I love getting an error. When, like, it's kind of like, there are a few times I actually really enjoy getting errors, and that's when, the errors validate that the issue you were having was non-trivial. I like those errors because it makes me feel like I'm not an idiot. All right, we're include again. We're going to create the input. We're going to run it just to see if we still get the error, and then we can go from there. Yeah, so now we're going to input here, and now we're going to do histogram K out and see what happens. But the CPU version is working now, which is fine. We're going to have to mess around with it a bit, but at least the CPU version is working. This then would have to be specifically a compilation issue with the GPU. So let's just see how it goes. How's everyone doing? I hope you're all having a wonderful day. Night, afternoon, morning, evening, whatever time it happens to be your time. And yeah, feel free to talk about how your day's going. Part of the reason I'm doing this live is so that people can comment, they can chat, and we can hang out and all that kind of stuff. So if you have anything in particular that happened that was super, fun in your life, feel free to share it. I'm happy to hear it, Okay, so good. We do have an error here, which is great, which means, oh no. Oof. Okay. Jail get field, here it is, all the way up here. Jail F tuple again. No. Don't give me that. Don't give me this. We just had this one. Throw check size error. Do not give me this error. Holy crap. Oof. Okay. I've awoken. Hey, Nick, how are you? I hope you're having a great day. I just put up a PR in the algorithm archive about adding a .node Jekyll file in the algorithm archive. I think this fixes some of the issues with the GitHub build. I think those issues were specifically because GitHub Pages thought that our file, like any Markdown file, was natively Jekyll. So if you also think that might be the issue, feel free to merge that in. I asked you to review that one because I genuinely didn't know. Okay, so crap. Looks like we have another error that is like literally the same error that we had before. Luckily, we know how to fix this type of error, and that's fine. Let's just kind of create a minimum working example and see if we can figure it out. Can you describe the GitHub build issue? Yeah, sure. Let's just go ahead and do that right now. GitHub.com. Let's go to algorithm archive here, and then we're going to go to the GitHub pages, and then go to this guy in here, go to the details. Basically, it's not super, anyway, it just says the tag method on line 109 in contents forward Euler method.md is not recognized, is not a recognized liquid tag. Note that this happened specifically after we removed forward Euler.md from the summary. And the only like similar error I could find, I actually put in the PR here, there, here, there, and they basically said that this is a bit recent, but I updated my blog, blah, blah, blah. And they basically said that their solution was to put a no Jekyll in there. And I Googled around and they were all saying that, part of the reason here is that if GitHub Pages sees a .md file, it assumes that it's a Jekyll file. And so that's why the no Jekyll would help. I think in the original algorithm archivist.github.io, we had a no Jekyll file, but I might have also just removed it. But yeah, this is the issue. I tried to view more details on GitHub Pages, but then it just gave me this link to like pages.github.com, which was completely unhelpful. And I didn't exactly know where to go from there. But yeah, I think this is a solution. You can feel free to look at it yourself. Let me just grab this, paste it over here. So yeah, we'll see if that fixes it or not. I just wanted someone else to look at it and see if that actually was the issue or if there was something more concerning happening, right? Also, I just realized we have 313 forks of the algorithm archive. 313 forks is actually quite, like, I don't know, I think that's quite nice, you know? I mean, look, we have 1,800 stars, which is also kind of nice, but the fact that we have 313 forks, I think is also quite cool, you know? I think the forks actually say more about the repository than the stars do. Because, like, obviously, we're trying to make the algorithm archive as good as we can, right? That's huge, like my passion for algorithms. Hey, yo, Bunga. Yeah, so I think it's quite nice. I really do think it's kind of shaping up. Now, look, we recently, as of yesterday, I think it was on Hacker News, the algorithm archive. I honestly don't think the algorithm archive is going to catch on until we have way more chapters. But I think the quality of the chapters we have now is decent, right? Like, on average, if you click on a chapter in the algorithm archive, it's going to be relatively good. I'm not going to say it's the best. There's obviously going to be issues, and like there's a 20% chance you land on a chapter that's not particularly good. But for the most part, I think most of the chapters in there are pretty good now. And this is why I'm happy to start merging in other people's work, because I feel like I kind of understand what we're going for, and I understand how to do the editing and all that kind of stuff. Anyway, we'll do more algorithm archive work in about an hour, I hope. I still want to try to figure out if we can get this histogram stuff working. So we've got a couple things to kind of mention here. The first is whether we can completely avoid this error or not. I feel like we can completely avoid this error. I feel like we don't need to do this. Like, we could write this in a different way. But I'm also kind of interested in seeing what this error is exactly. And how we have a string. Why do we have a string at all? I don't understand that. So we have unsupported call to Julia runtime JLF tuple. Again, pretty sure this is the same error we had before. And it says throw check size error for vector int 32 tuple base 12 in 64. I think we can just do this the same way as before, but we have to figure out what the check size error is, and why we're even running into the check size error at all. So here's what I'm going to do. I'm going to move this over here. I'm going to create a new terminal here, make this huge, and we're going to take a look at the kernel abstraction source code and just see if there's anything in there already for check size errors or not, and see if we just have to add another call to that. Hello, come on. Okay, and then I have to figure out what the check size error is. I actually don't know what it is. So we're going to cd into project kernel abstractions. 1 second here, kernel abstractions ls here. And let me just do grep-rl, check size. There's not anything here. Let's cd into source. L is here, go into vi macros.jl. Let me look for exact. No, it's not here. Where did I put it? It was going to be in compiler.jl. Let's go to exact. Here, okay, so here's the overdubs for the inexact errors that we added in just last week or something. So I think what I'm going to do is I'm going to dive into this, see if it's something we can easily fix, but I also need to find a way to create a minimum working example of this, and I genuinely don't know, I don't know how to create a working example for this, because I've got a feeling it's like, I just don't know. I don't know how to do it. So again, we needed the 32-bit casting for this algorithm to work, so that's fine. I think it's fair enough to put the 32-bit casting in here. What is happening with this code to create a check size error? What is a check size error in Julia? Unfortunately, I don't read Greek. I'm sorry about that. I wish I did. I know that the name is Laos. Probably should read Greek. Is that even Greek? Maybe it's not. Maybe I suck. I thought it was Greek. Google Translate. Let's go here to detect language. That's not Greek, is it? Wait, no, yeah, it definitely is. Women at least once in lives touched. What? Oh, yeah. Okay. I was getting this guy. I thought maybe it was like, okay, to be fair, like the only Greek I read is like biblical Greek and stuff. I'm going to ban you, man. So let's go over here and just kind of time you out. Where are we? Timeout. There we go. Done with that one. I'm sorry. Like, just, I don't know what's been going on, but the past 2 days we've gotten some like kind of trolly comments, you know? I mean, like, also, like, I don't know, we've got some trolly comments. I'm not going to dwell on it, but there's two things to note here. The first of which is, if you're making a joke about like people, I mean, like, if you're making a joke about people like being worse than other people because of their, I don't know, sexual exploits, like that's just gross, man. Like, why even bring that up? And second of all, like, who cares? I'm married, right? Like, what are you trying to say? Like, I don't really even understand why this is coming up. Anyway, that's it. I'm going to keep going. I realize it's a just forget it type of thing, but also, like, I kind of like calling out my trolls a little bit. Like, I get a lot of trolls on YouTube, and I find the number one way to keep trolls from coming back is just to, like, talk to them and be like, yo, man, shut up. Or, like, this isn't funny. Or, like, or like, be, like, really, like, just pretend you don't get the joke. Like, that's how you get rid of trolls. Okay, so let's see if we can create a minimum working example here. Write and quit. Write and quit. I have so many minimum working examples in this directory. I literally have 5 of them. So we're going to create minimum working example 6. Histograms.jl, minimum working example 6.jl. All right, let's go to vi minimum working example.jl 6. Okay, so this is the case where I actually don't know. I don't know what the issue is. So I'm going to guess some stuff, right? So let's go ahead and remove all the unnecessary stuff because we know all this is unnecessary. I'm going to modify the histogram tag kernel and everything. So it's just going to read in a single input. I'm just going to modify all this, guys. So it's just a very simple example that we can work with. Okay, in here we're going to make it so we just have a single input that's being read in. I'm an idiot. I think I removed the wrong call. Open this up again. I think I did remove the wrong call. All right, let's keep going. I'm going to remove... Yeah, I needed that bottom one. Okay, that's me. I'm sorry. Okay, we're going to remove that. And we're going to remove this. And then we're going to pop over here. And we're just going to have one input value. Sorry about that. DTI. All right, perfect. For the fun of it, I'm just going to put this all in one line. What's more fun than, condensing code? I can't think of anything. Anyway, I'm sorry. Let's go ahead and modify this. Here, there. So we have a single input to the kernel. Here we're going to remove the histogram stuff up here. So this could be in a number of different things. I'm just going to try to replicate it really quick. And here we're just going to read in a single input. Again, DTI dot, perfect. Okay, I'm pretty sure the line that's breaking is this line down here. Pretty sure. What I'm going to do right now is I'm going to run this again to make sure we get the same error. So we're going to do Control-C, Control-D, run Julia. How do I actually run this? I think I just can read in an input. So let's just run it and see what we get. Are we outputting anything? Well, let's actually go up here because I think I screwed up some stuff. Yeah, so down here where we do the shared histogram, here, this is stuff I'm going to remove. All this down here. So this should be fine. Let's go and do include for the minimum working example 6. .jl. I think it's going to work, and then we just, because we're not actually outputting anything to the histogram, we just read in a single input. I think this is going to work just fine. I'm also going to go in here, I'm going to modify all of the histogram tags to be just ftest again, and then CG. I misspelled it. Let's try it again. Here, histogram tag, and we're going to change it to ftest. All right, CG. Yep. Perfect. Right, this go over here. Control D, Julia, include. Let's just run it. See what happens. What's the worst that could happen, right? All right, let me get some water as well. It's currently 5 o'clock. I've been streaming for about 2 hours now. I don't know how long I'll go today. It might be another 2 hours, might be another hour, might be another 3 hours. I don't know. I'm just letting you guys know, we've been at this for 2 hours. So if you just kind of came in stream and you have no idea what's happening, feel free to ask questions. Ultimately, what I'm trying to do is get at a core error with kernel abstractions right now. So basically, we were writing some code, we ran into this huge error message, and I'm just trying to create a minimum working example of that error message. Now, if you don't know what kernel abstractions is, it is basically a way for you to write a single piece of code that executes on either the CPU or GPU. And so that's kind of what it is. So recently, we've ran into a bunch of issues that kind of work on some architectures like CPUs, but they don't work on GPUs. See you, Nick. Thanks so much for coming in. I will see you hopefully later, maybe. I don't know. We'll see. But I'm definitely doing algorithm archive work in like an hour or something like that. We'll do a little bit more chapter work in like, I don't know, like hour, 2 hours. Just basically as soon as I can create this minimum working example, I'm fairly confident that we can actually fix this pretty easily. I'm fairly confident it's kind of the same issue we had before with the previous error that we had last week. And now that I kind of know how to fix it, I think we can just do it, And then create a pull, kernel abstractions pull request and all this kind of stuff. Okay. So let's go ahead and run this, see what happens. So we're going to do, I guess it's just going to be ftest. By the way, Lamp24, thank you so much for following. Really appreciate it. I think if I just do ftest of zeros of 10, this will work because it's on the CPU. I think I need to wait for that. Okay, perfect. And now let's put this on the GPU and see if we get the same error. So we should get just a huge, massive, just giant error that's like impossible to understand unless you're incredibly smart, like I am. No, I'm not. But like we'll get there. Okay. Give it a second. It's doing a lot of pre-compilation stuff on the GPU. Here's the error. Perfect. Okay, so there's a couple things that this could be. Oh gosh, darn it! Look at that. Look at that beautiful error message. I've been scrolling for 30 seconds and I can't find the top. There is no top. I'm literally at the top of the terminal. Like I can't scroll any higher. This, oh my gosh. If this isn't a beautiful error message, I don't think I've ever seen one. My word. Okay, let's just scroll all the way down. All right, let's see what we got here. I'm going to go over here. I don't know how to fix this, if I'm honest, but the first step in fixing something is finding what's broken. We're fairly certain that the creation of the shared histogram is fine. So what I'm going to try next is I'm going to try to change this. So instead of doing a shared histogram, I'm actually just going to, I'm just going to read the shared histogram in directly. And then here I'm going to do just all of the data here. And let's just try running this again and seeing if this generates the same error. Or rather, let me try removing all the colons and seeing if we get the same error. So here we're going to do that, write that, go over here, include. Now we're going to run this again. Okay, we got the same error, but it might just not have compiled everything. So let's include everything again and try it again. Let's just see how it goes. And again, guys, if you have any comments, questions, concerns, ideas, just let me know. Here we go. And let's see if this generates an error, because then we know it's an issue with the function call. And it could just be that there's an @inbounds in front of the tag bin, and maybe that's the issue. Maybe that's the issue. And the @inbounds should definitely be on the inside. Now that I think about it, almost certainly should have been inside. So let's see what happens if we remove that @inbounds and see if that's the issue. Nope. There. Let's just do, I don't know, R spaces. Okay, write that, go over here, Control D, Julia, include, and then we're going to wait one more time, see if it works. And then if we know it's a problem with the @inbounds call, which again it could be, maybe we avoid it. Like, you know, this could just be an error where like people should know better than to do an @inbounds on a function call, and maybe I just didn't know better. Like that could just be how it is, you know. Let me get some water. Oh, nope, we still get the error. Wonderful, perfect, okay. So we know it's not with the @inbounds call. Could be with the inlining of the next function. Let me take a look at this error message, see if we can get anything. So it says call through a literal pointer. That doesn't help us in any way. Call through a literal pointer. Let me try. I feel like we're getting an error per thread, which is not helpful. Oh, no, here we are. JLF tuple, perfect. Multiple call sites, unsupported call for JL get field, core.variable, multiple call sites. This is not helping me in any way, shape, or form. String n, again, I don't understand how we're getting a string here. String vector. Okay, but we are getting an error, and this probably is going to be something that we can fix, or we can kind of scrub through. Is Julia CUDA as powerful as C++ CUDA? The answer is yeah. Look, it is the same, right? You're doing the same CUDA PTX pointers, the CUDA PTX calls in the end. It's just as fast. And in fact, it's way more approachable as well. But here, just for the record, the issue that we're running into isn't specifically with CUDA. It's an issue with a library we're using called kernel abstractions, which allows for you to do heterogeneous computing. That is to say, allows for you to write a single piece of code that can execute on both the CPU and GPU, or either, whichever you configure. So here's that configuration step, which again, super nice for programmers so that they can write parallel code for both architectures at the same time. But as you can see, the error messages are just next to impossible to decipher. The CUDA error messages are slightly better, but they're still kind of a bit, I don't know, they're still not super nice. Where would be a good place to learn algorithms? There's a bunch of different places. It's totally up to you. Nikolaevich99Tech, thank you so much for following. Really appreciate it. So we're actually currently writing a book on algorithms called The Algorithm Archive. I'm not saying this is the best place to learn algorithms. We're missing a lot of very important algorithms. Like, for example, sorting and searching, we don't talk about. And the reason for that is that it's the arcane algorithm archive. If other people want to contribute sorting and searching chapters, I'm more than happy to merge those in now. But I kind of see this as an attempt to look at algorithms that people don't typically cover, like algorithms people don't see that often. Like, for example, the approximate counting algorithm was a good one. Computus is another good one. We have flood fill as well, which, I mean, people know about, but I feel like we went to in a lot of depth. Anyway, the point is, if you want to learn about any of the algorithms we have here, also the coconut build here is definitely broken. This line is wrong. I guess we need to figure that out. Maybe I'll just tag Amaris on that as well. But basically, you can switch between all the different languages here. Yeah, you switch between all the different languages, and So if you want to do Huffman encoding, you scroll down to the code, which is down here, and you can just switch between those languages as well. We provide some description of data compression as well, and we're basically putting a bunch of different algorithms in there. I guess I'll give you a link here if you're interested. As for other ways to learn algorithms, gotta be honest, this really depends on who you are and what algorithms you're trying to learn. If it's for an algorithms class, just use the algorithms textbook, as a good resource. Also could be a good resource, right? Yeah, so the thing is, for me in particular, like it also depends on how you learn. Like I don't learn super well from video content, and so it's kind of like you give me a video series, I'm like I don't really understand this, but I can learn very well from a book, right? So it just kind of depends on who you are and how you learn. Unfortunately, I don't really have that much. I don't have too much good advice on learning algorithms because I usually just read the papers, which I don't know if I suggest or not, but I do actually very much enjoy reading papers. So that's me. Okay, let's go back over here. Sorry. And let's see if we can figure out what the error is. So I think, sorry about that. I think what we can do is we can recreate this error. Let's just remove everything we know we probably don't need. So we have the input in here. What I'm going to do is I'm going to modify the tag bin function to have only one value, and that value is just the input. So we're going to do dt here, and now we're going to do control D, Julia, include, and try it one more time. Thank you guys, really helpful. Yeah, unfortunately, I don't have super good advice, but, I'm sure other people have advice here and also on Discord. Here, I'll give you a link on Discord. Also, I need to go here anyway. Let's go to create invite, copy over here, control V, yes, over here, paste, wonderful. And then I also need to go here and say, wait, why is super saying so cool? Let me go here and just say at Amaras, noticed some line numbers. Just mention that here. Books I really like: Algorithms by Sedgwick and Wayne, and Algorithm Design Manual. Oh, right, yeah, I've definitely seen these books as well. Okay, right, so that was a link to the Discord. Feel free to ask there, and let's just keep going. Okay, so I'm going to modify this so it only has one input, which is just input, and see if it still breaks. Let's do dt here, and let's do input. Okay, include, try it again. It gave us an error, but again, I'm just going to recompile just to be sure. Include, and then we're going to wait on the next call. Now, okay, to be clear about this, I think because all the functions are going to be inlined, probably you'll already have access to like the, input of a particular value at a particular time. So what I'm going to try next is I'm going to see if we already have access to if we already have access to input in this function or not. So the next thing I'm going to do is Control D out of here, and I'm going to try tag bin without any calls here and up here as well. Okay, let's do include, and then we're going to run minimum working example again and see what happens. Again, give it a second. At this stage, we're just trying to create like a small piece of code that gives us the same issue. It could be that we're in a for loop as well. That could also give us an issue. So we're just slowly but surely trying to see what still creates a problem. And again, this actually could be a bunch of errors like all put together. I had not yet considered that possibility. Usually I think that, let me see if I can scroll up. Because actually some of these error messages are like dramatically longer than others. But this is a copy to error. Okay, unsupported call through a literal pointer. Let me see what happens if I do, what if I do at inline here? Include, wait. I'm always afraid it's not actually properly compiling the kernel. I know it should be, but like, I feel like I just need to re-include it and just like restart Julia every time just to make sure, All right, we're going to wait on this. I'm almost positive it's going to be the same issue as before. So the next thing I'm going to try is taking it out of the for loop, maybe. Or maybe it wasn't even the function call at all. Maybe it was this line. Let's just see. No, okay. Well, let me just double check. If it was that line, I mean, I was just digging the wrong hole, you know, like, I don't know. I wish there was a better way to debug this type of stuff. The problem is because we're on the GPU, it just gets super confusing. I guess the easy way to check to see if this is actually the problem is just remove tag bin, because it could also be in this for loop. Now that I think about it, it could be in the size command. Well, we found the problem. It wasn't in tag bin at all. Was not in tag bin at all. Include. Try it one more time. Oh no. Oh no. Okay. This is fine. It's fine. I mean, to be fair, pretty much everyone knows the other dimension of the shared histogram, and running size on shared histogram is probably not something people typically do because you have to compute that every time, and you already have not an analytical form, but like you already have. Yeah, okay, yep, that's definitely the issue. Okay, so what I'm gonna do next is what is the issue? Oh my gosh, what is the issue? I'm actually confused now. So this breaks, right? Yes. This is currently breaking. So what part of this is breaking? If max element is greater than n, we know that this was working a second ago. All we did was change this to 2D. Histograms.jl. Let's hop down here and see if this is working. I'm going to comment out all of this stuff in here. Okay, comment this out down here. That'll work. Write this, go over here. We're going to include histograms.jl. There we go. Create some sort of input. And now we're just going to run, what are we going to run? We're going to run histogram k out here. See if this gives us an issue. Because otherwise, I actually don't understand how this could give us an issue, or how the other one is giving us an issue, because it's literally the same code, I think. I mean, it seems like the same code, but like it could be wrong. All right, give it a second, see if it's actually doing anything. And yeah, we'll just see what kind of errors pop up. That's just the type of stream it is. We're just looking for errors. Okay, so there's no error in this code. Perfect. Quit here. Let's go into the minimum working example 6. Okay, let's take a look at the other code again. There is an issue with this code. Histograms.jl. We said we are doing the max element, then we say if input of TID is greater than the minimum element, we do at inbounds shared histogram of input. I'm genuinely not seeing the difference between the two of them. And we just put them side by side. VI minimum working example 6.jl. And let's just take a look at, I realize you can't see the left kernel super well, or the left terminal super well. I'll make it bigger if we need to. I'm just kind of going back and forth between the two of these and seeing if I can find the difference. So we have TID, LID at uniform GSN, shared histogram, at inbound shared histogram LID is equal to 0, at synchronize, at uniform max element is equal to 1. For minimum element is 1 to group size of n. Max element is equal to this, totally fine. If input of TID is greater than min element, and less than max element, perfect. Is it because... Oh. Yeah, okay, I now see the problem here, obviously. I definitely see the problem here. Right, okay. Perfect. Okay, I'm gonna be... okay. The issue is that... No, I don't see the problem here. Because we have if the input is greater than minimum element and less than max element, We do at inbound shared histogram of input of TID minus min element plus 1 is plus equals 1. Okay, I'm going to be right back. Give me a minute, and we're just going to keep working on this. So, yeah. 1 second. All right, give me 1 minute. I'll be right back. Okay, I'm back. Sorry about that. Right, so let's see what we can do here. Right, so before I left, we were having troubles basically figuring out where the error was in the kernel that we were looking at. So I tried to create a minimum working example here, and it seems to me that this kernel is breaking, even though it's like a direct replica of this kernel, and I can't quite figure out why it's breaking. So that's kind of where we're at right now. I'm just kind of messing around. So Control D, run Julia again. We're going to try to include the minimum working example again and just run it and see if it's still broken. Let's go into VI minimum working example 6. .jl. Okay, so let's run it again. And we should be running, where is it? It should be wait on ftest of Kuray of 0s of 10 and see what happens. Let me get some water. Yeah, I don't really have much more to say. I've been streaming for about 2 hours and 30 minutes now. Again, I'm not entirely sure how much longer I'm going to go on today's stream. Gosh darn it, what is up with these issues? I just don't understand. This error message is insane. It is unsupported dynamic function invocation call. So this one is different than the error message that we were getting before. This is not the same as the JLF tuple one. Oh gosh. Compiler B, it happens. So again, the issue here is not so much like, it's not so much a problem with CUDA. It's not so much a problem with the CPU. It's an issue with the fact that we're like, in order to compile this so that it can run on either the CPU or GPU, you have to kind of go through the entire compilation pipeline, and some of those functions happen to like allocate an unnecessary tuple or do things that just aren't allowed in that process, specifically for the GPU. And so in this in that framework, you have to kind of like work around those functions somehow. And so we have to figure out exactly what function is broken so we can work around it. The problem is I figure out, I just can't figure it out. I can't figure out what's broken here. And it's not giving, obviously it's not giving me a line number, right? And there isn't really anything I can debug this with because you can't go line by line through a GPU kernel, and it works just fine on the CPU. InButASM, thank you so much for following, really appreciate it. Okay. So what are we gonna do then? How do we fix this? Let's just keep trying to find the error, I think, is what we're gonna do. If I remove this line, everything works fine, I think. Let's go ahead and include again. We're gonna run this. Okay, I said that and it still broke, but maybe it didn't recompile properly. Let's try it again. Oh man, the problem was I just finished one of these errors, you know, like I just finished getting through one of these like kind of impossible to debug types of things that like take forever and like you end up fixing one line of code after a week of work, you know? I hate those errors, but you get them all the time and it's fine. You just fix them as they come along. But man, I don't want to have to do it again. Like otherwise this entire month is going to be spent just dealing with like literally errors with kernel abstractions that could have been avoided. So this is working just fine. Perfect. Is it the generation of the shared histogram? I guess maybe it could be in the linearization of the data. Could be because this is now a 2D array, right? So let's just try doing like an @print in here of @print size of shared histogram. All right, there. Let's try running that. Let's do include. And run it again. Okay, of course. Write this, go over here, Control D, Julia, include. Oh, right. This is because our input's just a bunch of zeros. So our min element here, okay, let's just change it so we're reading in a bunch of ones then. And this should print out a bunch of stuff. I think. Let's just see what happens. Genuinely speaking, I don't know what's happening. And that's fine. Like, it's fine not to know. But at some point, you gotta know, right? Like, I don't know. Oh, man. Let's just see what happens. I'm just tired is what I am. Okay, so this ran. Obviously, it ran. Let me try... so what is the issue here? We're reading in the input of TID is greater than max element. Min element, and min element is going to go 1 to group size. So our input of TID should always be, so what's our group size then? Our group size is going to be 256. Our group size is going to be 256. What we could be running into in this case, so let me do ones of 256. Or how about we do something different? How about we do rand from 1 to 128, and we do 256 of them. Let me spell rand correctly. Let's try running that. Okay, this output a bunch of values. We have 32, 8. Perfect. That's what we wanted to see. So next what I want to do is I want to print shared histogram, this of 1. Okay, let's do include again. Wait. Okay, that obviously didn't recompile. Wait, include, wait. Perfect. Okay, let's just run it again. Julia, include, and now we're just going to try it one more time. What I fear might be happening here is that we're unable to access a two-dimensional array in a 1D way, which is, you're always able to do that on the CPU without any issues, but on the GPU, maybe this is an issue because of like, I don't know how you do the indexing and stuff like that. So I'm trying this one more time. This should work, but the one that I'm expecting not to work is, I don't know, group, let's just do 10 or something. It doesn't really matter. Again, this one should work, but the next one I think might not work. Okay, that one worked, but it didn't print anything, which is weird. It should have printed something. Why did it not print anything? I'm not entirely sure, but that's okay. Let's go over here, remove this guy, write this, go over here, Control D. Oh, okay, well, they're all printed now. Wonderful. Julia. And let's just do, we're also going to do a new line here. That should be fine. Write this, go over here, include, try it one more time and see what we get. Yeah, let's just see what we get. All right, we're going to do this. and I'm staring at the code and I'm hoping, I'm praying that we get something useful, you know? I don't know. I want this to break. Because if it breaks, we know what the error is. It didn't break. Okay. Let me try one more thing. And what I'm going to do is I'm going to comment this back out. And I'm going to do this. And now we're going to try include. Run it one more time. I don't know why we printed anything there. Julia. And we're going to do include. Okay, I think I know what's wrong with that line then. And it's a different error. Oh, no. I spent all that time debugging an error that we didn't even have to. Let's run this. It's going to run, even with that line commented back in. And the reason is that we were running into an indexing error. Okay, so now let's try to figure out if we can make that other error appear again. It's fine. It's fine. We'll get there. Okay, good. So that works. So I'm going to DD all this over here, and I'm just going to say the following. Check of input. And up here, we're going to create a function. Check of input. End. That's it. Include. All right, let's keep going. Julia, include. Try it again. This is one issue I have, specifically revising code in Julia with kernel abstractions. There's, issues with it in terms of when things compile, when they don't compile, all that kind of stuff, It's kind of a pain, but fine. Ultimately, this stuff is going to be ironed out. The more people use it, the easier it is to iron out this stuff, So yeah, we'll just see what happens. So this one worked. Crap. Why did that one work? Why did that one work? Okay, let me try input of colon. Julia, include. Try it one more time. Here. And yeah, let's see what happens. Yeah, I mean, the problem with doing all this kind of stuff on stream is that it's super hard to adequately express all the stuff that's going on in my brain. So it's not like my brain is too big for streamers or for viewers to understand. So that one broke. Perfect. I think this is the error that we're looking for. But it's super hard to just explain, this is why I'm trying this thing. This is why I'm trying this thing, There we are. JRF, tuple, wonderful. Here's my next question. Is this specifically on a function call to a subarray? I think that's what's happening here. I think a function call to a subarray is what's breaking this. Look, you shouldn't be doing this in kernel abstractions anyway, but I guess it should be flexible enough to allow for that to happen. So here's what I'm going to do. I'm actually going to just double check that that's actually the issue. So we're just going to delete all of this in here. Oh, we're going to delete all of this in here and go there and here and there. Run that over here. Control C, Control D, Julia, include. I'm really gambling here, but I think this is the issue. And then we're going to do, we're going to check that out. If that's the issue, then we know what to fix. We got it. I think it should be easy. I think what's happening is, my guess right now is that in the creation of a subarray here, so we're creating an input, we're creating a subarray, which happens to be all the elements, but we're creating a subarray. And my guess is that in the creation of that subarray, it has to check the size of the subarray to make sure it's less than the size of the actual array. And in doing so, I think that's what's failing. And I'm not sure why it's happening. I'm going to try one more thing just to see if I can twiddle this down a little bit more. And we're going to say input, this is going to be equal to 0. I don't think I can do this, but let me just see if this also breaks. Julia, include, And if it also breaks, then we got an even easier error to mess with, you know, like, or an even minimized, an even more minimized minimum working example. Okay, so we went from trying to implement something that I've been trying to implement for months and trying to get that done today to trying to fix another error with kernel abstractions. But, you know, okay, the way I see it is fixing open source code can be rewarding in its own way, you know, and like working on this kind of stuff actually can help a lot of people. So it's kind of worth it. Okay, right. That was a thing that just happened. An illegal instruction was encountered. CUDA error, an illegal instruction was encountered. Error 715. It must be the colon. I'm going to do something dumb here. Here's what I'm going to do. I'm going to DD here. I'm going to change check. I'm just going to say input of TID is equal to 0. Okay? And I'm going to make it so it doesn't take in any inputs. Well, let's just see if that runs. It shouldn't. Yep. We're going to include again and see if this runs. The reason I'm doing this is I'm seeing if we don't need to read in the subarrays at all. I think the answer is we probably don't. I think that all the variables are just accessible by functions that you're going to be reading in. This is just, let's just see what happens. And then see if this is even something we need to fix with kernel abstractions or not. Because maybe it's not. Maybe we're okay. Right. This is going to say TID doesn't exist. I think if I run this on the CPU, it's going to break as well. Let me just double check. Here. TID not defined. Perfect. Let me try this again. Just check. Well, let me do the following. Let's do input of this. And we're going to say input TID. TID. All right. And let's try running this. Include, wait. That one works. And of course, it fails on the GPU. Okay. So I'm going to sit here and say, yeah, okay, maybe this isn't the best way to write the code. In fact, it probably isn't. But the fact that we're running into unsupported use of an undefined name. What? Control C, Control D. Julia, include, and then we're going to wait on the CUDA version. We know that the CPU version should work, but I'll run the CPU version as well just to make sure. And then hopefully we'll have a minimum working example after, I don't know, 4 hours? No, I mean, I've only been streaming for like 2 hours and 40 minutes, so it's not been that long. You know, like we'll get there. I'll do some algorithm archive work in just a bit. Let's go here and let's do wait. This is on the CUDA array, so this one should break, I think. And then we should have the CUDA version, or the CPU version that should pass. So, yeah, I hope everyone's having a great day. Again, yeah, okay, this one's broken. Let's try the array version as well. Here. Okay, so this one works just fine. Yeah, you know, I can check. Yeah, it works just fine. There isn't really an issue here. Perfect. Okay. Then let's take a look at the CUDA error one more time. Best day. Oh, I'm happy to hear that. And I hope this is the same error that we had before, which is unsupported call through a literal pointer. This is not the same error. It's surprising that this is a different error than the one we just had. So let me just say, let me just do this. Control D. Julia, we're going to run include, and we're going to wait on the CUDA version again and see if it produces the same error that we had before. Oh boy. Okay, so wait on the CUDA array. Again, we're doing literally nothing in the function call. We're literally just reading in input : It obviously works on the CPU. It obviously doesn't work on the GPU, and we can argue as to whether we should disallow this behavior or not. Totally fine. But the fact is, it does seem to be allowed on the CPU, so it should also be dealt with on the GPU, whether we disallow it entirely or not. Okay, let's go up here, check to see if we get an error. Oh gosh, darn it, give me this. Yeah, what is this? See, now I don't understand how we're getting a string here. Like, where's the string coming from? Throw check size error. Okay, we can at least deal with the check size error. Let's just see where that. It's probably in like core or something. Let's go back over here to kernel abstractions. Core.throw an exact error. So what do we have here? Let's go into Julia, and let's do core.throw an exact error. And what's this one that we're looking for? Throw an exact error. So let's do base.throw check size error. Can I just edit this? It's not a function call. Also, why is it acting on a string? So it's working on throw check size error for vec int64 and tuple of base 1, 2. How do I get this error? Let me see if I can figure it out. So we're going to go check size error, Julia, and let's just take a look and see if we can figure it out. Non-scalar indexing broken for array partitioning. Oh, this is SciML, which means it's probably based on kernel abstractions anyway. Let's go here. G. Let's see if we can find the error. Undefined variable error. Check size not defined. How do I get the size of an array? What is the check size error? Let's see. Julia on Ubuntu code. I was really hoping for something a bit more. Okay, let's go into the Julia source code then, and let's just kind of dawdle about. All right, we're gonna go here. We are going to cd into builds, Julia, ls here, git branch, git diff, git reset hard, git diff. We're gonna have to remake that in just a second. That's fine. Grep. Throw check size error, and then we want to, it's just throw check size error. No, that's what it is. And we want to do grep-rl. Okay, give this a second. It's in multidimensional.jl, and then a bunch of other things. So it looks like probably the one that we're looking for is multidimensional.jl. Cd into base, and then multidimensional. Then we're going to go into vi multidimensional .jl, and we're going to go into check size error. It says it's on line. It's on string. It's multidimensional.jl line 881. So let's go here to line 881. Here, function generate unsafe get index of n body. Okay, but how? Okay, what are you calling though? You're calling throw check size error on line 881 of multidimensional.jl. To be fair, it might be a different line number. So let's see, what do we have? Throw generate, let's look for check size error. Perfect. It says throw dimension mismatch output array. Throw dimension mismatch output array is the wrong size. Expected SZ got size A. Okay, good. So this is the error that we're looking for. Great. Let me get a little bit more water. Okay, so how do we fix this? So the issue is in the allocation of the string. Is that the issue here? Must be. It must be in the allocation of the string for the error output. The allocation of the string. Well, no, that's not something I can fix. Okay. I can create an issue here. I'd love to create a PR though. Throw dimension mismatch. Output array. Is the issue here just that it has a no inline? Is that the issue? That could be the issue. Let me take a look at some of the integer logic here. So let's do at edit int 32 of 1, 10, whatever, it doesn't matter. Line 602 here. At no inline meta, it could just be the no inline. That's the issue here, which forces it to like generate the string through the compilation pipeline. That could be it. So what we could do is we could try really quickly just to change our throw check size error to be. Yeah, let's just see what happens. So I'm going to go over here. Let's just go to quit here. Control D. We're going to cd back into kernel abstractions. I think you need to go one more directory back. Kernel abstractions, and then we're going to go to cd into projects, kernel abstractions, L is here. And then we're going to go into cd source, ls, and we're going to go into vi compiler .jl. 1 second, and then we're going to go into inexact here. I'm just going to copy one of these lines, paste it down here, and we're going to modify it so it's base dot throw what is it? Throw check size error. All right, that should work. And then in here, we're just going to see what happens if we directly put in the line that's supposed to be over here. So it's just going to be throw dimension mismatch here and there. I'm not confident this is going to help in any way, shape, or form, but let's just do Control D, Julia again, and let's just see if it actually does anything. It might say that the issue is now with kernel abstractions and the issue is no longer with base Julia, but I mean, that's a step in a direction, you know? So we're recompiling kernel abstractions, and this is happening because we set kernel abstractions to be, like built locally. Okay, let's see what happens. We might have a few of these that we have to fix, but let me get some water. Okay, we still got an error. Wonderful, perfect. It's probably the same error as we had before. Undefined initializer, similar overdub. No, this is actually a different error. This is going to be an issue with CUDevice vector, undefined initializer, tuple int64, invalid use of name A. Okay. Duh. Okay, that's an issue then. Base.throw check size error args, and this has to be args. Let me double check. What is this guy doing? It's throw check size error of A and then size. And so should it be args of 1? Expected SZ. So this should be expected args of 2. And this should be args of 1. Okay, let's see what happens here. Control D. Julia, try it one more time. At least we're calling the right error, right? Like this is the error that we just put into kernel abstractions, which is nice. Look, I gotta be honest. I can create a test for this as well, I guess, if this works. But it's kind of like I don't. Do we actually want to create a test for this? I'm not really sure. I'm not even sure if this should be allowed behavior. So I think if this does happen to fix things, I'm just going to create a PR, explain what happened, and then say, look, yeah, it's not even working, but I'm just going to say, look, I don't know if this should be accepted or not, but undefined initializer, called a print to strings xs and base strings.io, okay. Output array is the wrong size, expected args2, instead got args1. Unsupported dynamic function invocation call to print to strings xs in base at strings.iojl. Right. Okay, so at the very least, we know that the issue here is with the compilation of like an output to string. Now, let me think. Okay. Look, we can completely avoid this problem, right? Just completely avoid this problem by just directly inputting the function that we're trying to update. Here, let me just comment this out for now. Write and quit. Let's go into let's go over here. Control D, sorry, and then we're going to go to vi minimum working example 6.jl, and just to make sure that we can do this, let's just do input of colon equals 0. I think this is going to work. Oh no, this one's going to break because this one's going to break as well for another reason. Yeah, that's going to break for another reason because we can't do broadcasting. Pastmeester 19, thank you so much for following. Really appreciate it. Okay. let me go back to the histogram example. What are we trying to do? We're trying to grab blocks of 32, and we're trying to use those blocks of 32. So I don't need to grab. I don't need to grab a subarray, is the truth. I can get around this without using a subarray. So maybe the actual answer here isn't to just mess around with kernel abstractions, but the actual answer here is to mess around with the histogram so we don't need to grab a subarray. I think I might still create this as a minimum working example issue, just to say, hey, this is an issue, but I think maybe this should be disallowed behavior anyway, and just say that. And just say, hey, I ran into a bit of an issue. I genuinely think that this shouldn't be allowed and that we should just have a catch for this, but this is what it is, you know? So let's go ahead and just create that issue. And then I'm actually going to take some time. Actually, I might call that at the end of stream. I'm super tired right now and I'm a little bit hungry, so I might go get some food. I've already been working on the algorithm archive a lot today, so I don't feel like I need to work on it too much more. So yeah, maybe that's what I do. Maybe I call it today after doing that, and I just kind of take a second to figure out how we're going to do the histograms again tonight, so that we don't run into the same issue that we ran into today, where I didn't have a clear idea of how we're going to write this code. So I create that. That way we know exactly what we're going to do with the code. And then once that's done, we can hop in tomorrow, we can write that code, we can get the stuff done, and we can just go for it, you know? So I think that's what we'll do. Besides, it's kind of a quiet day anyway. It seems like, you know, obviously there are a lot of people here, like that's not the issue, but it just seems like this is something that's kind of hard for, like it's hard to do on stream, like I said before, because it's very difficult for me to properly express everything that's going on in my head in a way that makes sense to people who are just popping in at random. That's what I'm trying to say. So with that in mind, I think I will just go ahead and create the issue and then go from there. All right, we're going to quit here. Yeah, quit here. Perfect. And let's create the issue on kernel instructions. github.com. And let's just say here, I'm going to create the issue. New issue. All right, hear me out on this one. It's going to be broadcasting a creation of a subarray for I guess function calls results in an error with what is the error? Throw check size error. All right, let's just go ahead and write this down. So here's and let's just write it in. So I think I just go to minimum working example 6, grab this guy, put it here, there, and I just want to say down here, gotta be honest, I think this behavior should be explicitly disallowed, but if we want to support it, but I could imagine where people want to index along different, I don't know how to put this. One Ganyali, thank you so much for following, really appreciate it. Gotta be honest, I think this behavior should be explicitly disallowed, but I could imagine a case where people want to index along a different subarray or something. The reason, let's see, I recognize it's not particularly useful. I think there are almost always workarounds for this, but what's the error when we run this one again? Let me try something really quick. Let me just do this equals 0. And I believe this gives us a different error, Julia. Include, what's this error again? I think this one does give us a, this one gives us a, like an explicitly disallowed error. Wait, here, I think it says, like scalar indexing is disallowed. I think is what, that I think is what we should be given. I think that is what we should get. Danny too, thank you so much for following. Really appreciate it. Okay. If we don't get that, oh no, we get this, right? Illegal instruction was encountered, right? I'm not entirely sure what we should be getting there, but yeah. Admin 01331, hey, how are you? I hope you're having a great day. Okay. So, gotta be honest, I think this behavior should be explicitly disallowed, but I could imagine a case where people want to index along a different subarray or something. I think there's almost always, I think there are almost always workarounds for this that make sense. As a note, like input colon equals 0 is also should probably also be disallowed for similar reasons. However, if we want to support this type of behavior, let's see, behavior. Behavior is spelled with a U, right? I always spell behavior with a U. Am I misspelling behavior? That's how I always spell it, with a U. Behavior. Yeah. Yeah. Okay. Definition of behavior. Is this the British spelling? Do I just always use the British spelling for some reason? Okay. Yeah, apparently I use a British version for behavior. Also, I use British spelling for the word gray. I prefer it with an E. Even though I'm from the US. I don't know why, but for some reason, some UK spelling just sticks in my head. Even though okay, I really shouldn't be rambling about this, but the UK spelling is generally harder to deal with than the US spelling, right? Like color, they remove the U. Okay, it's one less character, it's slightly easier to read, you know? Like it's just generally a little bit easier, you know, like all this kind of stuff, right? Now, that said, for some reason, it sticks in your head better, and I don't know why. Like, you know, gray with an A versus gray with an E, you know, one of them is British spelling, the other is US spelling, and, you know, I always spell it with an E, which is a UK spelling, but with the A is the spelling that is most common, you know? I use center and color, but English is not my mother tongue. That's fair. Like, center, for example, is another one that I find, like, ER instead of RE, I don't know, like, who cares? Like, we're talking about, like, you know, this is a essentially programming stream, right? Like, so the differences between different, like, English language, I think rambling about English language differences should be, you know, the top of our list. Gray, like say, bay, hey, yay, lay. I think you're right. I think ultimately AY probably does make more sense, but I always spelled it EY for some reason. Gray, yeah, I guess you're right. I don't know. What is CGP gray? CGP gray. It's EY. Yeah, it's EY. Has to be EY. Did I, okay. I thought I lost my issue. I was in the middle of writing an issue. We talk about the English language, then I lose all my issue because I just decide to search for something on the wrong tab. Okay. As a note, putting input colon 0 should probably also be disallowed for a similar reason. However, if we want to support this type of behavior, at least for we could create an override for we can create an override for what? For the oh, come on. For the check size error. The issue is that it allocates a string to throw the error. The issue is that it allocates a string to throw the error. If we want to support this type of behavior, we could create, I think this is what I should say. I'm not sure if this behavior should or should not be explicitly disallowed. I am not sure. That's what I'm saying. I'm not sure if this behavior should be allowed. But I could imagine a case where people want to index along a different subarray or something. I think there's almost always workarounds for this that make more sense in parallel. I think as a note, input should be probably also be disallowed for similar reasons. For a similar reason. However, if we want to support this type of behavior, we could create an override for the check size error. The issue is that it allocates a string. It allocates a string for the error, and I'm just going to put it here. Okay. Yeah, let's just grab this guy there. Yep. And open this there. Paste. Okay. And let's just go there. Okay. Sure. I'm leaving this as an issue because I actually don't know what. I'm just leaving it as an issue just to let you know it's a problem. Pirate Cypher, hey, thanks for following. Okay. Oh, I just realized admin 01331. I realized your name is in kanji. I don't know if that is by kanji. I only know Japanese kanji, but I don't know Chinese. But I think it's one or the other. Char3176, thanks for following. Really appreciate it. Okay. The issue is that could allocate a string for the error. Leaving it as an issue. I'm leaving it as an issue because it's not pressing to fix, but I figured someone should mention it. It might be related to, and I'm just going to paste this here because there was actually that one issue with SciML that had a similar error, check size not defined. Let me do this in SciML. Oh gosh, I found it in screw it. Let's go here, paste that here. There we go. And we should get the issue. Yeah, non-scalar indexing is broken for array partition. Here, Cyclops error, Julia 1.1. Let's go there. Was this fixed? It was closed. Fixed by 116. Workaround base changes for multi-index array partition. Okay, whatever. I'm just going to leave this as an issue and just say, look, it's an issue. It's not immediately pressing to fix, but at least it's an issue because it's not pressing to fix for me. And I didn't quite know how to create a yep. It might not, I don't have anything that's related to. I will say, for the record, I did try something like this, but it obviously didn't work. I'm going to say obviously, even though maybe it's not obvious, but I don't know. I don't know what's obvious and what's not obvious, but I'm going to use the word obvious. I'm just going to say it didn't work. No, I'm not going to use the word obvious, but it didn't work. Okay, let's go into CD, back double directories, CD one more directory, into projects. ls here, we're going to CD into kernel instructions, CD into source compiler, ls here, vi compiler.jl, look for inexact here, and we want these lines here. Paste, just remove that and remove that. Perfect. Okay, I'm just going to submit the new issue. Again, Okay, creation subarray for function calls results in error with row check size error. Here's a minimum working example. Gotta be honest, I'm not sure if this behavior should be allowed, but I could imagine a case where people want to index along a different subarray or something. I think there are almost always workarounds for this that make more sense in parallel. As a note, input I should probably also be disallowed for a similar reason. However, if we want to support this type of behavior, we could create an override for the check size error. The issue is that it allocates a string for the error. There, okay, sure. I'm leaving this as an issue because it's not pressing for me to fix, but I figured someone should mention it. For the record, I did try something like this, but it didn't work. Also, what's going on with these? What is up with these blocks? Does that always happen? Should I just? I thought it would automatically wrap, but it clearly didn't automatically wrap, which makes this kind of difficult to read. Hey, Cobalt, how are you? Whoa, wait. What? Wait, what? For the record, okay, you added a middle name, and I think last time you came here, you didn't have the middle name either. No, you added the middle name, and I think I made the same comment last time. I think that I had forgotten. The middle name was what threw me off last time. I just got a message. Let me check something. I saw a cool thing. I saw the algorithm being mentioned on Reddit today. Oh, is it on Reddit? Oh, let's see how that went. If you want to post that, feel free. Sorry, I have to check something. Let's go to here. I got a message. Okay. You got listed as RSE. I think it's fine. Feel either way. Okay, sorry about that. I need to make sure people don't see this. Perfect. And let's go here. Yeah, feel free to get the link. So the truth is, I don't know if I want the link or not, because people are going to be mad about the algorithm archive. They're always mad about the algorithm archive. And the reason they're mad is because they think it's either like Rosetta code or like something else, you know, like, so the truth is it's closest to numerical recipes, right? Like that's what we're getting at. And I think people get angry at the algorithm archive because it's kind of shared prematurely. I know I've been working on it for years, but it's kind of like, it's not at a state where it's like, you know, the explanations are so good that people are like, wow, this is the best thing I've ever read. And it's not at the state where like it's so expansive that people are like incredibly happy to, you know what I mean? I don't know. They're not always mad. Even the HH stuff from yesterday went okay. What was the HH stuff? Oh, Hacker News stuff. Yeah. Let's just see what they say. Should I read the comments? I feel like I shouldn't read the comments. There's an endless loop bug in the first link on the main page. What endless loop bug? Endless loop bug. 4 comments and 1 comment for someone who didn't understand the goal. I guess that's fair. Endless loop bug. What endless loop bug? I'm gonna comment and be like, hey, what endless loop bug? Hey. Wait, what endless loop? Is that a bug with... What is an endless loop bug? Should I know this? Is that the GIF is just playing? Astro users stuck in an endless loop bug. Probably the most hilarious bug I've ever seen. Maybe with a specific browser? What is the endless loop bug and how do I fix it? Let me check something. Having an infinite loop bug on this while loop. Introduction? I don't know which one he's talking about. The first link on the main page goes back to the main page. Oh, right. I see. Yeah, that's because the main page is also the README for the GitHub repository. And so because of that, we don't know if you're looking at it from GitHub or if you're looking at it from the Algorithm Archive website. So the solution to that would be to either change it so the README is not the same as the Algorithm Archive homepage, which is fine. Like, it doesn't really matter. It doesn't change that much. The other thing I need to do, I actually do have GitHub sponsors, and part of the GitHub sponsors is that, you know, I say that we're going to create a sponsors page for you, and I haven't done that yet. And so I feel like I really need to do that. And there's a few other things, like just little bookkeeping things like that I need to do, and I just haven't done yet. Okay, but I've been streaming for 3 hours now. We got some work done. We did some algorithm archive work. I need a quick break, guys. Like honestly, I'm quite tired right now. I don't know if I said thanks for following Char3176, but thanks for following. I think I said thanks for following Pirate Cipher. I remember that name. But yeah, let me just take a quick break and just chat for a bit. I mean, how are you guys doing? Is everyone doing okay? I just need like 2 seconds to just refocus and like get everything in my head, or out of my head. I don't really know what I'm talking about anymore. Right. Shouldn't we have issues for all of those? Yeah, I think we do have issues for all of those. Let's just go here. Here, sure, algorithm archivists. Let me check the pull requests as well. See if this one was recently merged. It looks like it was. So now let's take a look at the, let me take a look at the, not CI testing, look at the GitHub pages and see if it built. Yeah, built. Okay, good. So we now have the algorithm archive building again. Perfect. Issues should be sponsors. Okay, we don't have one. That's fine. I'll just create the sponsors anyway. Right. I guess we could create an issue for the infinite loop thing as brought up by Reddit. I'm doing really good. Chased a motorcycle thief. Really? Bought a house. Made more money in stocks today watching the AMD presentation of Lisa Su than by doing my actual work. That sounds really interesting, man. Like, so stocks are one of those things. Some of my friends have recently got into stock trading. And like, it's one of those things I wish I would know more about, but I feel like I don't have enough knowledge about how everything works and all this kind of stuff. Like I have money to invest. In fact, I should in principle have enough money to invest that I could, if I really tried, make a significant amount of money off the stock market, but I just don't know how to do it, if I could make a 10% return on investment, I could in principle make more money than I'm making via all of YouTube and Patreon and Twitch and everything else combined. If I could manage to do that, but I feel like 10% is quite high. I don't know how to do 10% off the stock market. But maybe I'm wrong. Maybe 10% is easy. I have no idea. It just seems to me like a 10% return on investment is like rather high, right? Anyway, it's gambling in the end. I did a good look at algorithm trading, and stable algorithms perform worse than high interest bank accounts. Right. So the other thing, yeah. So I kind of felt that was true. And for example, I looked at some of these algorithms as well, like stopping algorithms and stuff for that. But I just didn't get anywhere with that. I did 100% on AMD in 1 year, going long. Okay, to be fair, there's always going to be those people who do super well in the stock market, right? And you sound like one of those people who are doing really well, who are one of those people who are doing really well. Yeah, that made sense. But there's always all those other people who are constantly gambling and losing a bunch, I don't know. I need to invest. I need to learn about the stock market. And maybe I do. Maybe I spend some time doing that. Okay. Right. Whew, I really need a break. Okay. I've been streaming for 3 hours and 16 minutes. Let me think about what I actually want to do here. I don't think the PR with Licht was updated. I don't think so. It was not. Oh yeah, you could do option trading, but that's much too risky for me. So this is stuff I don't know about. Like I actually don't even know what option trading is, if I'm being honest. Get some more water. But yeah, so really quickly, as in terms of like the future of the algorithm archive and stuff like that, I really am going to be using the algorithm archive as a way to bring people from, where they are on YouTube to basically research papers that we're publishing, right? The PID chapter is in the works. Right now, the cryptography chapter looks like it's going to be merged in. These guys, I asked if they wanted to get it merged in as well, or if they're willing to work with us as well. But, look, I got to be honest, as far as the chapters are concerned, there was a long time. In 2018, the algorithm archive was going strong. We worked really hard to make the algorithm archive really good. But I had to take a step back in 2019 because I was focusing on my thesis. And then in 2020, I was focusing on working at MIT. And then in 2021, I've been slowly but surely rebuilding everything. And now we're finally at a state where like the community's good again. Like we're getting there, and I really want to keep growing. I want to make sure that we don't lose this momentum and we keep going forward. It's just these PRs were put out in 2018 and I just did not have, it wasn't even the time. I didn't have the mental energy to do chapter reviews because they just take so long because you have so much editing to do and you have to make sure that they hit a certain bar of quality and, you want to make sure no one's feelings get hurt because saying, I'd like this change or this change. Some people might get a little bit upset thinking that, you know what I mean? There's all these things that you have to consider. And it just, my mind just didn't have the energy. I didn't have the energy to spend on that. You can copy my repo. Yeah, what's your repo? Feel free to link it. Okay. By the way, I don't know if I said thanks for following Zira's Tirapot, but thanks for following. Okay. What do I want to do? At most, I can stream for 2 more hours. Let me think about things that I could do with the algorithm archive for the next 2 hours. I'm a bit spent on the kernel abstraction stuff. I do want to spend some more time tonight, and it should be tonight, focusing on writing out some pseudocode to write for tomorrow's stream in terms of doing parallel histograms and stuff like that. So I do need to spend some time with that. And I think closing stream to work on that pseudocode might be particularly helpful. Have you considered reaching out to other universities about the algorithm archive for new chapters and review manpower? Yeah, so probably I should. But yeah, now that we have decent chapters being written, I think it's a good idea to do so. The problem is most of the people I knew at MIT, for example, they were in the Julia lab and they would be like, oh, I really want to make a chapter about this. But the problem was that they didn't like the fact that it was for every language, and so you have to be kind of you just got to be kind of I don't know, there's politics to play there. And I just, again, if I didn't have the mental energy to do chapter reviews, I didn't have the mental energy to play academic politics for things that weren't my actual academic job. Portable implementation of Type-C PID controller. Oh yeah, this is super cool. Big fan. So what is this for? It's embedded PID. This is for with a flexible API that allows users of third-party external and or internal filters for a better control backend with errors and exception handling. Yeah, this is quite nice. But I don't, what would you use this for, is I guess my question, because as a noob, I don't know what I'd use this for. Is this just a Arduino? Okay, there we go. Arduino testing code. Right. GitHub repository, Bitbucket repository. Right. Gotcha. Obviously, if it's PID, you're probably going to be using it on an Arduino or something like that. That makes sense. Okay. But yeah, as far as the future of the algorithm archive and stuff is concerned, I don't know. I've been going back and forth as to what to do with the YouTube channel, what to do with everything, and I'm just not entirely sure I have an idea of where everything's going. And so in 2022, I'm just going to be trying a bunch of different things, and we're just going to see how it goes. Okay. I think though, I think this is where I'm going to close it for today. I'm just quite shot. I'm going to focus on getting the pseudocode written for the histograms, and then we can go from there. Let's see if anybody's live. We have Lana Lux. We have Tim. Oh wait, I missed something. We have check the testing Python notebook. It can be used for heat control or drone stability. Oh, interesting. I have to go. See you, Cobalt. Hopefully I will see you tomorrow, maybe. Also, I'm super shot, guys. I think I will close it for now. I will be back tomorrow, hopefully. Again, I'm slowly but surely trying to get more stream stamina going so I can do these longer streams. And I will be hopefully live for, I did 3.5 hours today, hopefully going on 4 hours tomorrow. We'll see. Just slowly but surely, building up that stream time so we can do more and more. But that's it for now. Looks interesting channel. Good luck. Yeah, thanks for stopping by. Hopefully I'll see you around. Anyway, that's it for now. I'm going to go ahead and let's raid Tim. Yeah, let's do raid on Tim. So we'll raid Tim. Raid Tim, B-A-U-D-E-T. That is it for now, guys. Thank you so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys around next time for the next episode of Simuleos, which will be hopefully tomorrow. In fact, it will definitely be tomorrow. Hopefully for a little bit longer. And yeah, we'll just see how things go. Thanks again, and I'll see you next time. Bye, guys.